Not sure if this is fair game, this systems engineering. Oh, Creative Commons Attribution License. Reuse is allowed. Nice. Excellent. Here we go. So I'm going to switch this over to Space News now. And we'll go from there. All right, let's do this.
Engineering. Unit objectives for Unit 1 include explain systems engineering in the context of the aerospace industry, discuss the need for systems engineering,
Okay.
give an
I'll be back in a
overview
second,
of the
guys.
NASA system engineering engine and its associated processes, identify the attributes of system engineering. Unit 1.1, common definitions of systems engineering. Today we're going to talk about system engineering, what it is, what does a system engineer do when they come to work every day, and specifically, how does it apply to the missions that NASA does in the aerospace community. So a lot of the other material you're going to see in the course going forward, we'll get into the specific processes, the tools that are used by system engineers in their daily life. But today we're going to kind of back up and just talk in general, what is system engineering all about? A system is an integrated composite of people, and people in a lot of cases in system engineering, you're talking about all your discipline engineers. You have thermal engineers and power engineers and a whole variety of people that are involved in a system. You can't forget, sometimes people think of system as the product, which you see on the slide as well. The product is the actual physical hardware and software that you're going to develop as part of the system, but the people are just as important to developing a system engineering concept. So people and products, and then you see processes on this slide as well. So all three of these are kind of key to putting together a system engineering process and to managing a system development activity. So all of these are combined to satisfy some need or goal or objective that you set out for the system. So we'll talk more about that, but the goal is to kind of set a sight where you want to get. What does this system need to look like? How's it going to operate? And then what are the people, products, and processes I need to put in place to make all of that happen? The term system engineering really was developed in the 1940s. So there was people doing system engineering forever, right? Anytime there was a big project, when the Egyptians built pyramids, they had to have some processes, they had to have some way to communicate because the system was too big for any one or two people to be able to kind of manipulate the whole thing and make it work. So when you have these big teams, you need to have standard processes and tools. So system engineering has been around a long time, but the formalizing of it really developed in the US in the 1940s, so kind of in the World War II era. And the Nike missile program in the 1940s was kind of the first program where people started to use the term system engineering. The Nike missile program for the Army was a way to try to defend the country from jet aircraft that might attack. Jet aircraft were being developed, and the threat of jet aircraft couldn't be met by the traditional ground to air missiles that were available. So you needed high-speed, highly accurate missiles, and that was going to be a very complex program that involved a lot of different technologies coming together. And so the idea was it's a very hard problem to solve. You needed to bring together a team of engineers, and then you had to have engineers who could kind of make sure they were coordinated and that a system was developed out of it.
Realizing the importance of this anti-missile system to the protection of the free world, the Army is pursuing the development of Nike Zeus on a high priority basis.
When it comes to NASA's history, our first big effort in system engineering was Apollo. In the Apollo program, you were bringing together elements from around the country, and a lot of different systems and capabilities had to be brought together to make it work. And so system engineering at NASA really started to be formalized during the Apollo era. And at this point, and if you go online, there are many sources. The NASA System Engineering Handbook is available many different places online, where you can see all the different ways now that we have formalized that methodology. And that's again what you're going to be learning in this course. System engineering is a rigorous approach to designing, creating, and operating a system. And you know, there's other things too. You're trying to optimize the system to meet the requirements and the goals that you've set for it. Let's just talk about the two words. So first, this involves engineering. So system engineering at its core is engineering work. So engineering being the application of physics and math and science to solving some problem. There's something that needs to be done, and engineers step in and use the laws of physics and mathematics to go ahead and find some solution for it. And there's all kinds of different disciplines may be involved, right? So depending on the problem, there might be chemists involved, there might be metallurgists involved, but the end goal is to engineer a solution to some real world problem. And so there's a couple examples on that chart, something like building the Hubble Space Telescope mirror that you see on the one side. Or on the other side, you see some folks down at Marshall Space Flight Center trying to build a new type of lunar lander. And so in either case, you've got a team of people coming together and they're starting to look at the different ways to make this system work. Now, a lot of engineering can happen at the very basic level. So some engineers are only working on maybe the design of a battery for a spacecraft. Some engineers are only working on how to build the thermal coatings that go on the outside. Those very specific engineers that are working in their disciplines, that engineering can happen at a small scale level with small teams, and they can make changes just based on their experiences and develop a better and new product based on their experiences. But when it comes to bigger things, not just maybe a small application, engineering can become more and more complex. So if you go to the next chart, you see that the next part of system engineering is the word system. And so as problems become more complex, the engineering techniques and the processes that you need to use also become more complex. The number of people involved becomes more complicated. Here you see an example of the space station. So the space station is an example of a large system. You see that there's one element of it is the space station itself, the thing that's in Earth orbit, that's allowing crew to be on board and running experiments and doing all kinds of cool and neat things. But that's only one part of the space station system. What you see on the rest of the chart is all of the other elements that make up the system. There are cargo vehicles delivering cargo to the station that are coming from all over the world, Japan and Europe, from commercial vendors, from the Russians. There's also crew vehicles coming back and forth, a Soyuz capsule delivering crew and returning them back to Earth. There's also a lot of other elements of this system. You see some large communication satellites in the background. Those have to be able to relay data from the space station down to Earth so that people can communicate with that crew on board. There's also many facilities spread out around the world that have to be integrated together to make the station operate, to send information up to the station, to take the data from the station and send it out to the scientific community that needs to see it. So in this case, you've got a very large system that has to be coordinated with thousands of people that have to make this thing work. And this is where system engineering comes into play. And so system engineering, it really adds a discipline when you get to these large scale projects. So as engineering has become more and more complicated over the years, the idea is mature that you need tools to do this. You need processes, and those processes need to be standardized so that everyone speaks the same language. Everyone uses terms that everyone else can understand. And so that's a lot of what you're going to learn in this course is what are those terms and what are those processes that everybody uses. The system engineering approach consists of identifying and quantifying system goals. And so at the beginning, we'll talk that you start with an abstract idea. You'd like to maybe learn more about the universe and how planets around other stars might be able to be seen from Earth. And so I've got this goal, I've got this very high level thing that I'd like to achieve. Now I have to break that down and understand how can I develop a system to actually do that. So kind of use an example here. You see some pictures on this slide that maybe remind you of the space shuttle in some way. Maybe not exactly what you remember the space shuttle looking like, but we're going to walk through this process. And at the beginning, you've got this high level goal that you'd like to achieve, and maybe you have many different ways of developing a system to meet that high-level goal. So and it says the creation of alternative systems and design concepts. So along the way, as you try to meet this goal, you may try out a lot of different ways and a lot of different systems that might be able to achieve that goal. Now you want to go through a number of trade studies. So the system engineering approach consists of performing trade studies, design trades, where you're starting to look at, well, which one of these potential systems might be the best at meeting that goal? What's the optimal way of achieving what I'd like to achieve with the system? So the system engineering approach consists of selecting and implementing that best design. Best is maybe, some subjective, some objective. You have certain things like in the case of what you see here, this was actually some early design work for the shuttle. You have some best might be it has to be able to carry the most payload up into space if it's a space shuttle. But then best might be you think it's the safest way of doing it. So there might be some subjective and objective ways that you're going to consider what's the best way. And once you've selected an approach, you're going to go through and do some verification of that design. And we'll talk more about the term verification all the way. But verification says if I build that system, as I'm building it, I want to check to make sure that in the end, it's going to meet all of the requirements. Can it carry all that payload to space? Is that shuttle going to do all the things? Can it carry 7 crew members? Is it going to do all the things that I set out for it to do when I first wrote down my goals and my requirements up front in this process? And so as you go further into the process, you've verified that the system is developing the way you want it to meet that high-level set of goals. And then at the end, you're going to say, okay, I've got this vehicle, I've built it. Now, can it meet the goals that I set out for it at the beginning? So we're going to learn about a term called validation, where at the end, you want to know, will it operate the way I said it should when I set out to build this system? And so we'll learn about verification, where along the way, you're seeing if it'll meet each individual requirement, such as how much mass can it take to orbit. And then we're going to validate the entire system to say, as a system, does it do all the things? Does it operate the way that we expected it to? We'll talk about one of the major processes of system engineering. It's kind of the largest abstraction of system engineering is how do you move from an idea to a system that's completed and operating? And so here you see the Mars Curiosity rover. And we're going to use that as an example to kind of walk through very quickly to describe the process of system engineering. In the upper left-hand corner, you see the initial requirements that the scientific community came up with to come up with a new rover to send to Mars. They said, gee, we'd like to learn more about the geology of Mars, more about the atmosphere of Mars. And we'd also like to know if Mars could have had life on it at some point in the past. Was the environment conducive to having some form of microbial life develop and survive? And so when you're doing system engineering, you take those initial ideas, and now the first step is going to be to look to see if there are any tools out there that already can do what is needed to be done. So if you look in this case, there are other rovers that have gone to Mars. So could those rovers do the science that's being asked for? Could they answer the questions that you've come up with? And so there was the Sojourner rover, many, in the late 1990s, early 2000s. There was the Spirit and Opportunity rovers. So you can look at the science from those rovers and say, could they help us in answering these basic questions? The first step of system engineering is there some way to get this information without having to even build the system? Maybe we can just use an existing system. So in this case, the answer was no, that the existing rovers weren't capable enough to do the kinds of investigation that the scientists wanted to do on Mars, so a new rover would be required. You'll see that there's now the designing phase. You take this idea, you don't have an existing system that can perform the job, and you develop a new system. So you have to design it, you look at different ideas, how big should it be? Should it be a wheeled vehicle? Should it have tracks on it instead? So now the system engineering process is going through and doing trade studies, doing analysis of alternative options on how to perform this mission. And you're looking at which one is maybe most cost effective, which one can be done the quickest from a schedule standpoint, and which one would require new technology. And in the case of adding new technology to a mission, it might make it very capable, but it also might add risk that if the technology isn't matured on time, your whole mission might be set back. So you follow it along, that you go through a design phase, you come up with your concepts, you start to put out drawings of what this thing might look like. Maybe you look at 2 or 3 alternatives, designs, and you pick which one you think is most optimal for how you're going to do it. You see that you also might do testing. So here you see a prototype of the Mars rover. And you see they're looking at the mobility system, the wheels. How are they going to design the wheels? How is it going to move over the surface to be able to go into the rugged terrain that they wanted to explore with this new rover? And so they aren't building the spacecraft yet, but they're building parts of it in a demonstration mode where they can test it on the Earth and make some decisions about how to go forward. So you'll see that after you've come up with your design and you've done some prototyping, you're now ready to build the flight system that you're going to use. So, and this is all part of the system engineering process, from idea all the way through now to actually building the vehicle that you're going to send into space. So you see them working on the front end of the rover here and getting the drive system ready for testing. And so this is the integration of a vehicle, the actual development of a vehicle, after you've done a lot of pre-work to get to this phase.
Oh my God.
So a lot of people think that this is where most of the time and effort is spent, is actually building the vehicle.
Don't do that again.
But the system engineering tools and processes will tell you that all of that front-end work you did, looking at alternatives, doing trade studies, looking at different technologies, coming up with different designs and trading them off, That's the most critical part of the process, because
I'm not
changing
doing the
things
forms
back in
article.
that early part of the process, when you're working with designs and you're working with drawings,
Discovery,
the
go at
cost
throttle
of
up.
making changes is very small, and you can try to optimize your design. Once you start actually making the vehicle, any changes that have to be made because maybe the vehicle isn't meeting the requirements, it's not working the way you thought it would, those changes are going to be very expensive if you have to go back and change drawings and remanufacture components, and there could be a lot of ripple effect on your ability to meet your schedule, your ability to stay on budget. So you might be deceived into thinking that NASA spends most of its time building vehicles. We actually spend most of our time designing vehicles, and that's where system engineering tools really come in handy. So if you go down to the lower left-hand corner, you see that after we build a vehicle, it has to go through a whole series of tests. A lot of these tests involve putting the spacecraft, or in this case the rover, into an environment very similar to what it'll be like on Mars. And so there are large chambers where you could reduce the pressure, change the atmospheric components, put the sunlight onto the vehicle the way it would be coming if the vehicle was on Mars. And that's what you see here, is that you see a person inside the chamber testing to make sure that the brightness of the sunlight, or the artificial sunlight in the chamber, matches up with what you would expect at Mars before they run some type of environmental test where they might lower the temperature to be like Mars at night to see how the rover would survive at night. All part of the system engineering process.
That's right,
Again, making sure that the rover will work the way it's required to work to meet that high level set of goals that you set out for it at the beginning. So you've designed it, tested it, you got it ready for launch, and now you're going to operate the system. And so the end of the system engineering process has to do with actually operating a system all the way through to the end of its life,
I think I got all
and
of
then
them.
decommissioning it. So you'll learn a lot more about how these phases are translated into a whole lot of terms. The beginning parts are called Phase A and Phase B, the designing phases. The building phases move in, and the final designs, Phase C, the building of the vehicle, Phase D, and integrating it, and the Phase E operation. So there's all kinds of terms that will come up. But put it in the context of system engineers really work through a formal process to take an idea and generate an operational system. That's really the key. Click on the icon to read The Art and Science of System Engineering.
Cool. That's the stuff that I'm studying for Project Ares right now, guys. For our Kerbal architecture. That's the kind of stuff I'm working with. We got to do some trade studies about, how, for us, our trade studies are, if we're going to use like solid rocket boosters in our design, how would we move them to the pad if we can't move them in segments? Are we going to transport it singularly? Like, how are we going to get it to the pad? How are we going to put the thing together? How's the vehicle going to go together? And then like, how's a docking port on the system going to work? Am I going to use a capsule? Am I going to use something like Dart, only that something like Dart that doesn't suck? There's a bunch of questions to be asked, which, I don't know, I think that's really neat. The rocket crane shouldn't work. I know, right? Current systems engineering work. I'm part of a team bringing down an active test for planned maintenance and upgrades. Lots of coordination between disciplines and departments. I'm focused specifically on contractor work. Rizik, I like this. Systems engineering is very, very quickly becoming my favorite thing with spaceflight. That's my favorite, dude, like putting the whole system together and seeing the whole thing come together. That's my favorite. I really, really like this a lot. It's really cool. The more I read about it, the more that's like, like in Kerbal, like we sent the spacecraft out, right? But like I wanted to make launch pads, and we made launch pads. Like I wanted to see the end-to-end goal. That's systems engineering. I like it a lot. I really, really enjoy it. It's very satisfying, especially when you hit it out of the park. That's a really good feeling. How do we crowdfund for an NVMe drive? For EJ to cut the load times drastically, I don't know. Yeah. Also a systems engineer here. Good to see others. Soapbox, I dig this. This is like becoming my favorite thing. It is my favorite. I really enjoy this. All right, Switchio, what do you got for me? Let's see. I think I got most of them, but the Forbes one is behind ad blocker, and I don't care about that, so I'm not going to share that one. Let's see. What else do we have here? Thanks for the bits. 2020. All right. But yeah, fellas, so welcome to Space News. I hope you enjoy it. We got, Switchio has a couple of links here today. There's a couple of things going around here. Do I have the Sikorsky one? I do have that already. Okay. I got that Space News article, and then there's the EGS article as well. Or not EGS, there's the EGS tweets. I think I got everything. Hey, Thomas. Toaster. It's gross. Yeah, but anyway, yeah, the overall systems engineering goal is like my favorite thing. That's really cool. PLD, WS Hackaday, NASA hardware techniques, soldering space. Nice. All right. So, where do we start? Last please. Что? Surprisingly good news from our International Space Station operations. Apparently Anna Kickna flew to the U.S. to prepare for Crew 5. I couldn't find an article in English, but basically Rogozin confirmed it. Really? Alright. Okay. I mean, okay. Quite bonkers if I do say so myself. Yeah, we might see this through after all. Not bad. Also this, let me see. Oh, that's cool. Oh, they cut some of the aft flap. Ah, that's cool. Really shouldn't be involved with space, so that's cool to hear. Well, Dogmeat, one of the first things that I said, so on February 24th or 25th, like right after that, you know, the war in Ukraine, or special operation, or whatever they call it, started in Ukraine, right? I said one thing. Like, the first thing that I said is, look, I know what's coming. People are going to end up hating Russians, and they're going to hate this, they're going to hate that. Like, I didn't think Dmitry Rogozin would go off as much as he did. Like, as much as he does. It's kind of ridiculous. But, you know, for all his yammering on about Russia this, Russia that, Ukraine sucks, Russia good, whatever. For all that yammering on and on, operations on the ISS have pretty much stayed the same. Which is like, and once again, that feeds in the first thing that I said. The first thing that I said is like, stuff ain't going to change. It's not going to change too much. Everybody should keep their cool, because no one can afford, frankly, to do something dumb in space, and they're not going to. Which is good. That's good. That's good that cooler heads are prevailing, especially when it comes to international cooperation in space. That's a good thing. He said that operations are as usual until 2024. And they don't want to burn the bridges, but they still need permission from the government to go further. Bossy, it's so strange. It's so strange, man. This is not the first time I'm hearing this, dude. Like, Rogozin is, what he says to Russians is like, okay, I'm gonna keep my cool. We don't want to screw this up, blah, 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 blah. But when he goes on Twitter and posts, it's just crap posting. Like, what? I'm so confused. Like, I don't know what to do with my hands. Like, because on one hand, that's a really smart thing to say. You don't want to screw up ISS operations, right? But, you know, on the other hand, there's, you know, my special operation or whatever, right? Like, I don't know. It's just, can't help it, bro. It's Twitter. He gets drunk in crap posts, probably. Now that I would believe. Yeah, that I would believe. Yeah. It's very strange. But yeah, as long as we keep the cooler heads prevail, that's fine with me. I mean, I still think he screwed up by tanking the OneWeb contract, but hey, if Anna's gonna come here and she's gonna go on Crew 5, that's fine. That's totally good. Yes, please, let's not be dumb here, right? Like, was Twitter blocked in Russia? I'm not sure, Hand. Maybe? I don't know. Yeah, Nighthound, it's possible. Yeah, and that's the other thing that I kind of got at. Like some of the moves don't make sense. They make no sense. Like the one web contract and taping over flags and stuff like that. Like, dude, that was really stupid. You just handed a contract to SpaceX. What are you doing? Like, why would you do that? Right? Like, I don't know. I don't understand. I don't understand. When I say I don't understand, that's exactly what I mean. I mean, I don't understand. I don't get why you would do that. Why would someone do that? Anyway. Let's get into more space news here. So, this is coming from ESA. Ride into orbit secured for Sentinel-1C. A contract signed with Arianespace secures the launch for the third Copernicus Sentinel-1 satellite, scheduled to lift off on the new Vega C rocket from Europe Spaceport in French Guiana in the first half of 2023. Sentinel-1C will continue the critical task of delivering key radar imagery for a wide range of services, applications, and science, all which benefit society. Yeah, Metroid, maybe. It was, but everyone and their mother bypasses the block. VPNs, man. Let's see. So, the next Sentinel-1 satellite's going to launch on a Vega C. Interesting. That's the new Yeeter Plus Vega right there. Yeah, I can't tell. I don't know. Dude, and you know what, dude? That's the other thing that I said. Like, you know, I know a little bit of Russian. I've been following the space program for a long period of time. But just because I understand choice parts of the space program doesn't mean I understand how that country works as a whole. I have no freaking idea. And it seems like what's going on over there is a much more complicated thing. Because, dude, if it's one thing that I've learned about history, dude, countries just don't invade other countries because they feel like it. There's something deeply rooted that I just don't understand. And I don't want people to get hurt. Obviously, war is bad. That's really stupid, and I think it's counterintuitive. But it's also, at the same time, it's important to understand what's going on. Like, when I say I don't know what's going on, I absolutely mean it. I have no freaking clue. I don't know. This seems to be a much more complicated issue than just, oh, we're invading you because we don't like you. That's not how this works. That's not how countries get invaded. That's not the, you know, yeah. Nor do people here. I don't know what's going on. And you know what? We'll probably never know. Like, it doesn't make any sense. It just doesn't make any sense. That's what I mean. It doesn't make any sense from my perspective. But that doesn't mean it might not make sense for somebody else. Like, I don't know. What's the land? I mean, yeah, I guess. I mean, but I mean, we could play Hearts of Iron, dudes, and we know good and well that you don't just invade another country. You have to wait until the right kind of circumstances, right? Like, which means that, you know, they waited to the right circumstances to go into Ukraine, right? Which means that this is premeditated. Which means that this has been planned for a long time. At least that's what that tells me, right? Like, so what facilitated this? Like, is this like just bring back the good old days, 1991 and stuff? Like, what the hell's going on? Like, I don't know. It seems like that area of the globe is very, very complicated. It's a very complicated social phenomenon going on over there. And as an American, and I'm not trying to be ignorant either. I don't understand. I really don't. You know? Yeah, no, you got to build up the justification, right? Speaking of Hearts, when is it coming back? I'm not sure. Yeah, stress test, I mean, if it's like the Cuban Missile Crisis, that's something I can understand. You don't want your enemy knocking at your doorstep, right? Like, that's no good. That's bad for business. And I guess I can understand that. I don't I don't like it when countries invade other countries. I don't care if it's us. I don't care if it's them. I don't care if it's anybody. That's not a good idea. It's because people get hurt. And, that means that governments don't see people as, as that. That's just a statistic, right? Frick that, dude. I don't like that at all. just another number, right? How much of a freaking superiority complex do you need to have to order something like that? It doesn't matter. Once again, it doesn't matter if it's us, it doesn't matter if it's them. How much of a superiority complex do you need to, how drunk on power do you need to do to be able to justify something like that and get thousands of people killed? Or even millions in the case of World War II? You need to be a real piece. Please excuse my language. I apologize. If you're watching with your kids, please stop for a second. You need to be, just, give me a moment. Give me 15 seconds. You need to be a real piece of shit to think like that. A real piece of shit. But once again, let's jump back more into space news. Okay. Yeah, Ando, point still stands, am I right? But either way, fellas, I'm happy that Roscosmos knows, despite what Dmitry is saying, they know not to screw this one up. Because if the ISS goes, Roscosmos has nothing. There's nothing. There's no reason for them to exist, which sucks. It sucks because there's a lot of good technical personnel over there that really know what the heck they're doing. Yeah, Swishio, it's very strange. It's just probably self-preservation. There's no goodwill. You give them too much credit. When I say I don't understand, that's what I mean. If they're, if they're being pieces of crap, they're being pieces of crap, dude. But, yeah. Are we really just gonna time warp back to 1991? Was that what's going on here? It's gotta be, I don't know, man. It's gotta be more complicated than that, right? It has to be. Really? That's it? That's it? Or just, I want this land. It'll be of importance to me. That's it? That's it. Wow. That's basic as frick, dude. Nothing yet, Roadrunners. Well, Ando, they are a partner on the ISS. I've always said we're on the same team. When it comes to that, I don't know about anything else, dude. I just don't know. I don't think it's more complicated. But I too, North America without proper perspective. Yeah, dog meat. How do we know? Our countries invaded people left and right. Nobody batted an eye when we did it. And I know it's different. I know that's a false equivalency. I understand. But to be fair, I didn't like it when we did it. I don't like it when anybody else does it either. You know what I'm saying? This is a waste of time, dude. Yeah, that's it. He's just that basically corrupt. Man, Ando, that's so basic, dude. It's so basic. Ugh. But, yeah, Occam's razor, I guess, Ando, you're a lot closer than I am. I think you'd know more than I would when it comes to that. I default to your judgment, Yeah, Snib. I don't know, man. Yeah, Hoffman, maybe. You've known them for yeah, like I said, they ain't your neighbor. They ain't my neighbor. They're your neighbor. I have the Canadians. Canadians and the Mexicans. They're all right. They're cool. I like them. They're great neighbors. Interesting, Apollo. Interesting. The Canadians are planning something. Watch out for the Canadians. Dog meat, if it's one thing I know as a student of history, do not frick with people that want to be left alone. Okay? Especially if they live in a place that gets cold. I'll use a couple of past examples. Germany invaded the Soviet Union in 1942. Cold people that just want to be left alone. Look what happened. They ended up ripping their country in half. Okay, another example. Soviet Union invading Finland in 1940. The Finns just want to be left alone. Just leave us alone. That did not end well for the Soviet Union. No, that ended very poorly. Yep. It's a good example right there. There's plenty more. Napoleon with the Russian Empire, that didn't end well. Don't invade people that want to be left alone. And don't invade people that live in cold places. That doesn't end well. It never ends well. Ever. Like, favorably throughout history. It's not just World War I and World War II. That never ends well. Ever. It just never ends well. Don't do that. We shouldn't do it. Maybe we shouldn't do that. Maybe we shouldn't do that. That's probably not a good idea. So, you know, you guys can be planning something, but invading Canada, the U.S. invading Canada would be a very stupid idea. That would be a very stupid thing to do. Let's not do that. Because Canadians want to be left alone. They're just up there doing their thing. Be left alone, and they live in a place that's godforsaken, frozen all the time. No. Nope. Hard pass. So don't invade Michigan. Ohio tried to do that one time, and it didn't work. Ken, oye, ¿cómo vos está? I hear the Canadians are planning to take control of the Canada Army and dismantle the ISS piece by piece. So, I mean, you needn't look more than history to look at people that want to be just left alone. Do not screw with people that want to be left alone. That doesn't end well. It never does. Canadians are a threat to the U.S. They have amassed 90% of their population within 100 miles of the border. In an alternative history, if Canada turned communist, you think that the U.S. would have done nothing. No, absolutely not. Can't tell. That's what I mean. That's what I mean when I say I don't understand. Because look at what happens when Cuba had a communist revolution in 1959. Look at what the U.S. did. Relations between Castro and Kennedy broke down well, it was Eisenhower and Castro at first, and then it was Kennedy and Castro. Relations broke down really, really fast, and we almost ended the world over a freaking small island in the Gulf of Mexico. Yeah, so it's always more complicated than it seems. Every time. The U.S. didn't want communism on their doorstep because they were worried about the domino effect. Makes perfect sense to me. You got to be careful about this stuff. You know, that's why I haven't been weighing in on anything that's going on over there with the exception of the AN-225 because I know about that. Also, that Cessna's holding that wing up, man. She'll survive. Not really, but the wing will. That's good. Anyway, so check this out. Next bit of space news here. NASA EGS. The team continue to press ahead toward a terminal countdown for the wet dress rehearsal. This is the modified wet dress rehearsal that EGS is running to tank that core stage and make sure that all plumbing systems on the mobile launcher work correctly. Later, teams will perform a pre-launch walk down of the rocket and ensure the core stage is prepared for the upcoming prop loading operations. So, fueling it up. Burn your white building down again. Dogmeat, do you remember during the Battle of Britain in 1940, right? When the Germans switched from bombing military RAF targets to bombing monuments to, you know, try and break morale. And it didn't break morale. England got really, really mad. Yeah, you remember that part? Be careful what you wish for. Go ahead. See what happens. Nope, wasn't there for that. Come on there, bud. You burnt down the freaking White House. Oh, sorry, bud. Now I'm gonna have to obliterate your entire country. Oh, look at that. Oh yeah, look. We brought you some freedom there, bud. We'll take Alberta, thank you very much. What? There's freedom there. There's a lot of freedom there. We need to provide more freedom. Don't you understand? We already did that. Please take Alberta. You can have Alberta, to be honest. I mean, are you offering, or? Americans, huddle up. Huddle up. Americans, huddle up. Should we do that? It's not a bad idea, right? have oil. And I do like that. It's a trap! It's a trap! All right. Think about the bird of beef, though. I mean, Alberta is basically northern Texas. It's like... I vote no, we can't launch rockets from Alberta. Okay. Just keep sending the Canadian bacon and no one gets hurt. Russia does want Alaska back. No. No. No, that's not happening. Yeah, northern Texas, of course. Yep. That's a good description. Yeah, dog meat. I've met a couple people from Alberta in my travels. Yeah. Yep. Yep. Oh, boy. Fort Blunder. What happened here? Oops. Still, I'm from Alberta. Be careful. I'm just saying. I like you guys. I think you guys are all right. You like pickup trucks? I like pickup trucks. Those are nice. Oil. I also like that a lot. That's pretty good. You know, those are pretty cool. That last one was pretty cool. Rednecks all... I spilled some coffee on my keyboard. Oh, no. There we go. It's fine. It's mechanical. It'll be all right. That's not how that works at all, and I know that. All right, let's see. What's the next thing here? So, check this out. Sea last, and we have a lot of traps in the Netherlands. Yeah, it's just, water. Greenland still for sale? I don't know, you'd have to ask the Danish. Oh, now you guys wanted me to, now I want to play Hearts of Iron, but I don't want to play Hearts of Iron, but I kind of want to play Hearts of Iron, but I don't. All right, let's keep going. An absolutely stunning photo and more details of Rocket Lab's new helicopter. From the new press kit. Ooh. So, Rocket Lab's next mission is a rideshare mission on the Electron rocket from New Zealand, right? Launching from Mahia, right? And they're going to snag that sucker with this helicopter, this Sikorsky S-92. The S-92 is going to have a little tow hook on it, right? And that tow hook is going to have basically a fishing loom on the end, right? And if you look at the booster in this picture, you look at the booster with the parachute, right? See this drogue chute that's behind it and this kind of string that's right here? The helicopter will basically hook the lure on this thing right here, and then the helicopter will pull up, and if you pull up on that string, the parachute folds in. The parachute folds together, and then you can pick the rocket up. They're going to pick up a parachuting rocket down. Take a look. Or I could just, zoom all the way to the bottom. That's fine. Yeah, they're going to try this. The next mission, guys. The next one. It's awesome. Stop saying right. Play Hearts of Iron? I don't know, maybe. I mean this. Isn't that Romania? The demo? Yeah, right here. You'll see the demo. Check this out. Watch. It's actually really cool. So this is the next Rocket Lab mission here. That's true, Supercraft, yep. The Dutch word for stairs is trap. Dank. Swashblade.
drop location. And all traffic drop test commencing in 30 seconds.
Nice, Rizik. There you go.
Delta releasing in 5, 4,
3, 2, 1.
1.
Release.
Release.
Now that's a mass simulator, right? With the parachute rigging on it.
Romeo in position behind test article.
Watch this.
Initiating final catch approach.
See? When the line goes tight, it folds the parachute up.
Test article secure.
What the frick? Dude, if they do that, man. If they do that, that's gonna be damn impressive.
Romeo returning
So
to
this is the next mission. You don't know how difficult that actually is to do, man. Jesus. I hope so, RJ. Yeah. See, this is the part that I'm wondering. How are they going to set the booster down when they get it back? How are they going to do that? Is it just going to tip over? Doesn't that mean that the rocket engines are going to go into the dirt? So no seawater, indeed. Yep. Yep. How much does the stage weigh? Electron? Not very much. Really not much. It's very light because it's made out of carbon fiber, and it's very small on top of that, so I would guess that they have the land-based version of the Orca. I mean, yeah, Thomas, you'd ideally want to put that thing in like a catch net or something. That's grass, sir. It grows over the dirt. What? I'm from the city. I don't know what grass is, man. I don't know what grass is, man. We don't have that. Maybe they'll put landing legs on him. Yeah, maybe. They've shown pictures. Rocket Lab has shown pictures of the booster. They've shown pictures of the booster before, but they never. It didn't seem to have any landing legs on it, so I don't know. All right. Anyway, so a little bit of update from JPL over here. Check this out. Webb's telescope, the James Webb Space Telescope's coldest instrument reaches its operating temperature, so we're very close to getting some operational pictures from this thing. Yep, with help from a cryo cooler, the mid-infrared instrument has dropped down to just a few degrees above the lowest temperature matter can reach and is ready for calibration. Sweet. What temperature are we at? Miri initially cooled off the shade of Webb's tennis court-sized sunshield, dropping to about 90K. Oh. But dropping to less than 7K is required an electrically powered cryocooler. Last week, the team passed a particularly challenging milestone called the pinch point, when the instrument goes from 15K to 6.4K? Oh, geez. Wow, that's really freaking cold. It's a bit chilly. Yeah. Let's see. So that's good. Another step done for Webb here. Yep, here we go. They're almost done. hot side is, it's 56. Not bad, not bad, not bad. 127, I mean, that's a little warm. That's a little warm. What the frick, dude? Those numbers are insane. It's a little brisk. It's okay. It's okay. Can you press the metrics? Yep, we're almost to the instrument commissioning there. "56 Fahrenheit is shirt and t-shirt weather, guys. That's t-shirt. That's t-shirt weather for me. K is metric. Yeah. Yeah, that's really cold. Smoking like a New Englander. Yep, that's right. That's hoodie and pants weather. Dude, I remember Shoe Spot being down there during the winter, and everyone's like, everybody that's local was like, oh my god, it's 65 degrees out. I'm like, dude, 65 is short in a t-shirt, man. What are you talking about? Right, Ian? Yeah, no, they don't know. They don't know nothing. They don't know nothing. Oh my god. Perfect hoodie weather. Yeah, that's right. Yeah, Magellan, right. Okay, cool. All right, so a little bit of interesting news here. This is coming from ULA. So check this out. For the Orbital Flight Test 2, so this is Starliner now. Starliner is the next mission to go out of Slick 41. Yeah, OFT2. Yeah, Starliner, the unmanned flight test. You remember that? Remember that thing? Yeah, still there. So NASA's Pegasus barge brought Atlas V to the launch site. Huh. That is the barge that NASA uses to move SLS cores in it. It moved an Atlas. Moved an Atlas core. United Launch Alliance has positioned all elements at Cape Canaveral of the Atlas V rocket that will launch the second orbital flight test of Boeing CST-100 Starliner spacecraft from NASA Commercial Crew Program, crew missions. Unique circumstances required ingenuity to develop a different transportation plan to ship the Atlas V first stage booster from ULA's rocket factory in Decatur to the launch site in Florida without using the RS rocket ship cargo vessel. The arrangements ensures that launch preparations remain on schedule for OFT-2's liftoff next month. Oh man, another spacecraft about to launch. Tori said that the other barge is doing regular maintenance and checkups. Cool. Do you think that's maybe because the Antonov fleet is indisposed at the moment? No, Synerd. So okay, the Antonov fleet. No. Anything operating abroad, I'm pretty sure, is operating as per normal. Hostomel Airport, where in Kiev, is just a maintenance. That's just their maintenance depot. But yeah, it's not Volga-Dnipro, it's Antonov. Antonov has, their operations are continuing as planned, from what I understand, with the exception of 225 stuff, which kind of sucks, but it is what it is. Yeah, it's just, the planes around the world with the blue and white stripes on them. The Antonov 124s with blue and white stripes. Yeah, those ones are indisposed. Yeah. The Antonovs with the blue and yellow stripes, those ones are operating as per normal from what I understand. I could be wrong, though. I mean, it's been a while since I checked up on that. The last time I checked up on that was back in late February, so it could have changed. Circumstances could change. Who knows? But yeah, a side note is that, you can move around Atlas V cores inside of an Antonov 124. Subsequently, also a C5. They could move it around in a C5 if they wanted to. Yeah, Maney, there you go. The Antonovs that were parked in Leipzig are flying currently equipment to Poland to support Ukraine with literally anything. Yeah, there you go. Yep. Yeah, okay, so they are indisposed. Yeah, I think that would be the right way to say it, Synerd. Yeah. So, on March 31st, the 107-foot-long, 33-meter Atlas V stage began the journey from Decatur aboard a smaller open-air barge that could fit through an auxiliary lock at the Wilson Dam and bypass the lock closure on the Tennessee River. The one-day trek aboard the barge moved the Atlas V to the port in Luca, Mississippi to meet up with Pegasus. Cool. Oh, yo, look at this picture. It looks so small. Look at how tiny it is. Look, it's so tiny. It looks so small inside Pegasus. Hey, man, Manatee, what's going on? What is the Space Invaders game you have on your backdrop? That's Galaga. Yep. The one that's over here, my flight director. That man is playing Galaga. It's Galaga. Great video game. Classic. So, fellas, the Pegasus barge here is the barge that NASA used to move all external tanks to the Cape. So it can fit a rocket. Actually, before that, it was used to move Saturn V stages, if I'm remembering right. It's all the same barge. And they used it to move an SLS core. And SLS cores and external tanks are 8.4 meters wide. That little baby Atlas core is, what, 5 meter? It's small. It's tiny. It's so tiny in there. It's so tiny. Yeah, here. Yeah, Derek actually. Yeah, Vulcan has a great picture. There you go. Right. That's what it. This is you. This is the guy she told you not to worry about. I'm going to hell. I'm going to hell. Who's coming with me, man? Who's coming with me? The inside is still big. It was designed for Bolshoi Saturn V. Ogromny Saturn V. Ian's like, me! You know what? This is why no one wants to work with me. This is why nobody wants to collab ever. Oh, man. Jonathan Liberate T. X Inferus. Oh, boy. Why are you the way that you are, EJ? Cab over trucks are better. I'll take wrong answers for 500, Alex. I'll still say Alex. I don't care. It's always going to be Alex. I ain't saying Aaron, that's for sure. You could fit 2 of them in there. Yes. This is why you don't get to host launches. Yeah, right. All right. So, that's cool, though. That's cool that NASA's letting them use Pegasus. And it seems like it arrived here. So, once again, that's for the OFT-2. The OFT-2 mission, baby. Another Starliner launch. Oh. Dual engine Centaur. Dual engine Centaur. Stand back, ordnance is installed. Dual engine Centaur. Ordnance. Dual engine ordnance. Explosions and rocket engine. Yes. 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 Find some. Oh. That's cool, man. So the DEC is what's required to launch Starliner. So you have higher TWR, so you can launch on a steeper ascent profile. And why do they fly on a steeper ascent profile? To keep the G load down, so you don't liquefy the people inside. So yeah, they fly on a steep ascent profile. Believe it or not, Atlas V with the dual engine Centaur in the Not 22 configuration. So the capsule to launch Starliner, the capsule configuration that they run. Runs a very similar ascent profile to the shuttle, which is very cool. I thought that was neat. What is a steeper ascent profile? Okay, please excuse the crudity of this drawing that I'm about to draw you. I didn't have time to build it to scale or to paint it. So, all right, you have Earth. Welcome to Earth. Slap! Anyway. So, if you're trying to get up into orbit is up here, right? So, honestly, you're going to want to do something like this, right? Right? So, consider that like a nominal ascent, a normal ascent. Like if you're flying satellites into space, satellites don't really care about G-load as much as this, these bags of meat that we launch into space, people, right? So steeper ascent profile would be something like this. See the difference? Basically, in this area, it is steep. In rocket science, that's called a lofted trajectory. The shuttle flew on a lofted trajectory, so those SRBs didn't liquefy the crew. Yeah, any more than they already did. See what I'm talking about there? It's a steeper ascent profile, that's all. It's to reduce G-load, to make sure you don't kill anybody on board. Yeah, I don't think I need to tell you why. That's probably not good for it. Hey, wait a minute. Guess what truck it is? Guess what truck it is? Oh, come here, little Ferd. Oh, you did a little tickle. Good truck. Good truck. A little tickle. Look at that. That's a Ford L9000 or L8000. Ford used to make semi-trucks. They don't anymore because more profits or whatever. Yeah, no problem, Iron. Yeah. You know what the messed up part is? Atlas V is a small rocket. Small. No. Atlas V is pretty freaking big, dude. Tickling trucks? What am I tuning into? I'm not tickling it. I'm scratching it. Hey, when you have a dog, you don't give him a little neck scratch. Dog loves it. Truck loves it too. See, just it works hard. It's a good work truck. There you go. Oh, who's a good truck? Who's a good truck? This is weird, isn't it? Doesn't matter. Who's a good truck? That's right. Oh yeah, you're good. Good boy. ULA truck over the US went. Actually, yeah, that's a really cool truck. Okay, so interesting thing. ULA, that's an old truck. That Ford hasn't made L9000 since the 90s. ULA actually paid to have this thing restored because it's good at moving around. It's good at moving around rockets. They worked that thing to the bone, and then they restored the thing, and they still use it, which is really cool to me. I think that's really neat. That shows you how good that design is. ULA bought that probably. Actually, heck, ULA probably didn't even buy that truck. I'll bet you McDonnell Douglas or Boeing bought that truck, or Lockheed or something. I mean, that truck is from the 90s, man. It's as old as mine. It's as old as the 250. They take care of good machines, like this. And like this. And like this. See? Good machine. Chevy? Ugh. Actually, you know what's cool? Who knows what that is over there on the left? See this thing? Who knows what that is? No, not the trucks. Not the trucks, dude. Not the trucks. This thing. That's a Centaur. That's its upper stage. There's the rocket. That's the whole rocket right there. First and second stage. Hey. That's 50 subs.
Discovery, go at throttle up.
That 50.
Discovery, go at throttle up.
I don't know what to say. Yes, thank you. Well, that's a good way to start the day, I guess. Thank you. Whoever that was, I really appreciate it. Thank you. I hope you enjoy my useless information about trucks. But also, just because you did that. Tickle. See? Oh, it's a good truck. It's a good truck. Good truck. Yep. Also, I don't really know what to do with my hands. Seriously, no. Thank you, whoever did that. I really appreciate it. Jeez. Oh, I just thought of something really dirty. Nope, 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 nope. Not gonna do it. Not gonna do it. Next space news. Next space news. Next space news. Seriously. 50 subs. Thank you very much. That really helps me a lot. Thank you. Tell us, what color is the rocket behind that truck? I'm taking my time out. You don't get it. It's red-ish. It's red. When does that train for hell depart? Please, I must know. No. Let's go back into space news. Jesus Christ. I'm sorry, Chatty Murphy. It was an accident. I was having too much fun. I offer you a truce. The stickiest of the icky space news. You want to learn about space with the old boy, EJ? Now that you mention it, I think I'm bleeding inside my chest, but I got the medicine. Yep, alright, Ian. That's good to go. Stop it. Get some help. At least there's no your mom jokes. The only time I will ever make a mom joke, Alexito, the only time I will ever make a mom joke is when I'm talking about gravitational pull of planets. Because your mom has more gravitational pull than the sun. And you know what? If you're older and you're watching the stream, you can judge me all you want. That's fine. But you know good and well that if we want to teach kids this, it's got to be funny. Okay? You know good and well. You could sit here and you could say, oh, you got a dirty mind. Yeah, okay, that's fine. Or I could just tell them how it is and they could get bored. Just saying. Just saying. You got to make it funny somehow. Right? Got to make it funny, because if we dialed the nerd tree to like 15, people would not watch the stream. People would get bored. But, you know, if we incorporate some toilet humor into our education, and saying that doesn't really sound right, but if you do that, it, you know, people think it's funny. Gotta laugh somehow. You gotta make it. You gotta sprinkle on a little bit of humor every once in a while. Just, you know. Yeah, the Gen Z whisperer. You have to. Also add a little bit of randomness, but see, okay. If it's one thing that I learned about Zoomers, okay? Zoomer humor has to be random, but it can't be too random. If it's too random, then it doesn't make any sense. It has to be random enough where you understand the concept, but it can't be, but also it's kind of like, wow, that's so weird, right? It has to be half and half. If you just do a random thing like, that's not funny. People will be like, what are you doing? You know? But if you do, Will Smith, then it's funny. See what I'm talking about? Differences. See what I mean? That second one was funny because it's topical and you kind of understand it. But it's also really random. Yeah, see? I figured you out. That sounds just like humor with more steps. Shh. I don't understand it. I'm not a Zoomer. I don't get it. He's doing the chata. Oh, God. All right. Anyway, let's go. All right. So, Aerojet Rocketdyne. We're thrilled that Aerojet Rocketdyne Next Gen RL-10CX has been selected by ULA to help power its Vulcan rocket. 2 RL-10CX engines will power the rocket Centaur upper stage during each flight. All right. Propulsion, you can count to. On. All right, let's see what we got. RL-10CX, powering the upper stage of ULA's Vulcan rocket. Proven reliability. More than 500 flights. Unmatched performance. 3D printing drives affordability. Interesting, Lunprod. That's a lot of typers. Random equals funny. What is that, Kyron, with the bits? Hell, admit one. Oh, thank you. Thank you very much. They ordered 116 of them. Well, okay. So here, fellas, let me look at this. Let me look at this potato quality image. Guys. 300 by 600? Tell me that's Twitter downscaling, for the love of God. Do I look like I know what a JPEG is? Look at it. Look at it. It's been compressed. All right. Let me look at the size of the turbine machinery here. Oh, that's a huge nozzle. They do rocket engines, not JPEGs. Come on. All right. That's fair. No, that's a big nozzle on that motor, though. That's freaking huge. That's way bigger than the RL-10s that are flying on Atlas right now. That is a huge freaking motor. That's like, that nozzle's almost RL-10B2 big. That's really, really big. Downscaling drives affordability. You know, Wolfie, that's too real. That's too real, man. Damn. Almost as if it was sized for use in vacuum. All right, here. So here's the thing. The one that Centaur 3 uses looks something like this. This is an RL-10A41N. See that? That's kind of what Atlas 5 uses on Centaur 3 right now. Okay? Now look at that nozzle. Look at that nozzle comparatively. See the one on the right here? Wolfie, get out of the way! Wolfie, get out of the way! Oh, an anonymous person gifted you a sub. Never mind. See that right there? See the person standing next to it? That's how big this nozzle is. This RL-10CX is a gigantic freaking nozzle. That's huge. I think the nozzle on the RL-10C extends mid-flight. That's the RL-10B2. RL-10B2s are the one that do that on the Delta motors. They have screwed a threaded rod here that spins and it moves the nozzle down. See, there's 3 of them. 1, 2, and 3. Interesting, right? None of that extending nozzle shenanigans. Yeah, no, that's just a fixed nozzle. An anonymous Geeson gifted 6 subs. Wait, an anonymous gifter gifted a GSF a tier 1 sub, and then Geeson gifted 6. I'm confused. Yes, I am. Geeson, you've outed yourself. See? Look at the RL-10B. So this is a Delta 4 upper stage engine. A Delta 4 and Atlas 5 both use RL-10 upper stages, but they use very different variants of the RL-10. This right here, this RL-10B2 is what Delta 4 uses. And an RL-10B2 is what SLS uses in the ICPS as well. If I just threw a lot of acronyms at you, this is a Delta 4 upper stage engine, but also SLS uses a very similar type of engine to this. Because they use similar upper stages. That's really cool, actually. But it looks like for this new version of the nozzle, this new version of the engine, the RL-10CX, it looks like, guys, actually, to be honest, you know, for everybody saying, oh, great, another RL-10 variant, I'm looking at some really hardcore changes here. It doesn't have the cooling channels on the nozzle right here, which means that they've opted for a different manufacturing method. It looks like at the throat they have a different type of cooling mechanism. In this case, it's an expander cycle. Here, this looks completely different to any other RL-10s that I've seen in the past. It looks like the turbine machinery is similar, but it looks like I'm not sure if this is an ablator nozzle or what. The RL-10C 2.1 extends it as well. It's the same engine as the RL-10B2, but restarted construction. The C21 is being used on Delta 4 right now, and and Artemis 1 will be the last B2 flight. Interesting. Yeah, but Thomas, if you look at like the RL10C, right? If you look at the RL10C has, okay, so how RL10 engines are made is, now, back in the day, they didn't have any cooling nozzles here. You couldn't do a milled channel, okay? So what they did was they took tube stock. Seriously, they took metal pipes, kind of bent them into... They took a metal pipe, tube stock like that, and then bent it to be like this. Kind of like into a trapezoidal shape, right? So they'd hit it from both sides, right? And it bent it into a shape like this. And then they would take that and go all the way around, right? And then they would use these bands right here to hold everything together. See the tubes? The RL10's nozzle is just a bunch of tubes that are all kind of scrunched together. Seriously. That makes the cooling channels. The reason why they're using like a tube stock is so they can move the propellants through that. See? It's just a bunch of tubes pressed together. That's how they did cooling channels in the 60s. Nowadays, you can 3D print this, no problem, with the right sinterer. You can 3D print that. Or you could cast it. Either one. I mean, I think they're 3D printing with the RL10CX, but if you look at like a stereotypical RL10 right here, right? Look at where the dump here for the hydrogen goes. See that? That's actually not a dump. That's part of the expander cycle, to be honest with you. See that? Look at where that is relative to the nozzle, and now look at the RL10CX. That's a 3D printed nozzle with some type of weird cooling channel on it. See that orange part right there? That's actually a... Guys, I'll be honest, like, they've been making RL10s for a long time. RL10s go back to Atlas Centaur in 1961. The Centaur design is actually a Convair design, believe it or not. It was engineered by an engineer of German descent called Kraft Erich. Yeah. He kind of came up with Centaur, and I don't know who came up with the RL10. I think it was Rocketdyne at the time, but, you know, putting it all together in the Centaur with balloon tanks was Kraft Erich's design. But RL10's design hasn't really changed. It's kind of centered around these pressed together cooling channels for the longest time. Even on like SLS. SLS has an engine that looks like this, but with the extended nozzle on it. That's actually really interesting. The nozzle is 3D printed using a nickel-based alloy. That's actually really cool. That's one of the biggest like meta changes in RL10 production in its entire run. Most RL10 engines look like this with the pressed together cooling channels. Right? It's just a bunch of tubes that have been pressed into this shape and they go all the way around the nozzle. It's built like here. Wild West barrel. You guys, barrels like the stereotypical Wild West barrels like that just use an iron band to hold the whole thing together. Literally that. It's the same idea. Same idea, but with a rocket engine and not wood. That's how RL10 engines were made up until real recently, until this thing came along. Now, I'll bet you dollars to donuts because that thing is 3D printed. The cost is probably going to go way down on RL10s. And ULA block bought. You said they bought 116 of those things, huh? $461 specific impulse. No freaking way. No way. What? So, United Launch Alliance recently awarded the largest RL10 contract ever to Aerojet Rocketdyne to deliver 116 RL10CX engines for its Vulcan Centaur rocket. The new engines will support ULA as it works to fulfill its commitments under a contract they recently received from Amazon as part of the largest commercial launch contract in history. Yeah, Jeff Bezos literally block bought Vulcans. Yeah, he block buyed them, which is unbelievable for his internet satellite, for Amazon's internet satellite constellation. SpaceX should make the Starship RL10CX powered. RL10CXs are good, Hellfish, if you're going with an expendable launch vehicle or a reusable an on-orbit reusable upper stage. Starship needs that TWR, dude. Yeah. So Vectors aren't going to get to Force 61 specific impulse, but they'll get up there. So use them on HLS. Fun fact, Hellfish. Do you know why the RL-10 engine was made? I said it was for the Centaur. It wound up on Centaur. Do you know why they came up with the RL-10 design in the first place? It kind of has to do with what you said, spoiler alert. They wanted to use it as a lander engine because expander cycles are very throttleable. Yeah, very throttleable with an expander cycle. You can deep throttle an RL-10. On why they used Pegasus. Rocket ship is having its routine dry dock cycle. Oil change, barnacle scrape, the usual. Right on. Yeah, DCX use RL-10 A5s. That's right, Pigzig. Mm-hmm. Yep. Yep. Basically, for what SpaceX is trying to do with Starship, they need high TWR, not necessarily efficiency, because they're going for an on-orbit refueling style. For the lander, I mean, Hellfish, okay. Personally, if we're going to theory craft out stuff, dudes, I would want NASA to make an EUS-derived lander. You heard that right. Oh, okay, Dogmeat, I got you. So, yeah, that's right, Jock. The Vinci engine is the real deal. You guys should make a lander. I'm dead serious. Arianespace should take that Vinci engine and they should propose it as a lander for HLS. I'm 100% serious. You should do that. That would be a really good engine for that. That would be one giant lander. Any bigger than Starship? I mean, what the hell do you think MADV is? Personally, I think NASA should use an EUS for a lander. So an EUS is SLS's upper stage. For the Block 1B variant, it's this big. And it has 4 of those RL-10CXs in it right there. See them? See with the big nozzles? Those big 3D printed nozzles? Basically, launch an SLS, right? And launch an SLS with another EUS on top of it in a cargo configuration. And then just put the control deck up here, right? And then you take an Orion with a HAB module, right? And launch that on a Block 1B, okay? Orion with the HAB module will dock to the lander, and then the EUS, constellation style, will push the whole thing out and go to the moon. Or you could launch it on an SLS Block 1 and do LOR. You could do Lunar Orbital Rendezvous. Basically launch the EUS lander on one, send it out to the moon so it's fully fueled by the time it gets out there. This is taking into account that you can manage cryogenic boil off, but that's another story. And then get Orion to rendezvous with it at the gateway and then go to land with it, which is kind of what they want to do. But making an EUS-derived lander is not a bad idea. However, if I was going to do this, I would probably put the LOX tank on top. Which is that's what Lockheed wants to do with MADV. The reason why I would do that is to give it a wider base to land on. Yeah, because the legs would have to go somewhere out here. You know? Yeah, yep. The EUS would use the RL-10C21. Mm-hmm. Rumors of an ESA lunar lander are being announced. It's a good idea. If you could figure out a way to manage that boil off, you'd be good to go. It's not a bad idea. Not a bad idea, dudes. Anyway, that's cool. And once again, that follows the biggest block buy in U.S. history. Jeff Bezos bought, how many did he buy? What was it, like 41 Vulcan launches or something? 38 Vulcan launches? 38 Vulcan launches, and then 15 New Glenn launches, and then Ariane 6, he bought like 12 Ariane 6 launches. 38 Vulcan, 83 total. Unbelievable. Unbelievable. And guess what? He bought so many... Amazon bought so many freaking rocket launches that ULA is considering reuse. ULA is... not considering. It's not even considering. They're doing reuse. ULA is going to do smart reuse. They've been testing it quietly in the background, meaning that Vulcan's first stage, the Vulcan core stage, is going to jettison its engines, and the engines are going to land. They're going to have an inflatable heat shield, and they'll land out in the ocean, and then a helicopter will come and pick them up. And the heat shield, because it's inflatable, will act as a raft, so the engines won't dunk into the water. They've been testing it, which is really freaking cool. It's a very exciting time. I mean, especially we could say whatever the heck you say whatever the heck you want about Jeff Bezos, but man, that's literally $10 billion being pumped into the space economy. That's ridiculous. That's a lot. Hey, are you in a NASA station right now? No. No, Russ, this is just a background, dude. I wish. I teach people about what NASA does, though, and I've worked with NASA on things before in the past, but yeah, I teach stuff here. That's just a green screen, dude. What? Yeah. Buying should buy the smart reuse tech and put it on Block 1B. Helfus, what you just said would be like saying, hey, I bought a top fuel dragster, and because it has more horsepower, I want to put its engine in a Formula 1 car. It doesn't work that way, man. Don't get me wrong. I want SLS reuse as much as the next guy, dude. I want SLS reuse as much as the next guy. I really do. It would be cool to see smart reuse with SLS, jettisoning that engine section, but I'm not 100% sure how they'd pull that off. Could it be done? Sure, anything can be done. You'd have to redesign the core stage. You want to redesign? That's how you get a redesign. Yeah, Novus, I mean, core stage would have to be entirely redone, literally from the hydrogen tank down. Yeah, I would say at least from the hydrogen tank down. I mean, once again, I'm not saying that can't be done. It should be. That would have been a great idea, but that complicates things a lot. Getting those RS-25s back is not going to be easy if we choose to do that, because they need a thermal protection system like the shuttles. It's almost like we should have just kept using that and used that to assemble transfer vehicles on orbit. It's almost like it was built to do that. Hey, an anonymous gifter gifted Novus a sub. Right on. Did I hear SLS had a setback today? No, the wet dress rehearsal is going just fine, Kuro. Yeah. I now expect you to obtain a dragster engine in an old Formula 1 car. I've been bamboozled, not like this. Do we have any info on how the BE3U will compare to the RL10? The RL10, yeah, well, I got the RL10's info right here. It's in front of me. The RL10 uses a 3D printed main injector and main combustion chamber, as well as a 94-inch monolithic lightweight composite carbon. Oh, it's an RCC nozzle. Whoa! Look at you. Look at you. All right. All right. RCC, reinforced lightweight carbon or carbon composite, so RCC is the same stuff that they made the Space Shuttle nose cone out of. Yeah, Space Shuttle nose cone is made out of that. It can withstand a high temperature. You can use it to make a rocket nozzle if you want to. But in the past, RCC has been really difficult to make, because anytime you're working with any carbon-based composites, you have to put it in an autoclave and you have to bake it like a freaking cake. So it takes a while. But if they it looks like Aerojet figured out a way to 3D print RCC, that's a big deal, actually. Also the R68, that's right. Yep. Well, RCC is not ablative, Synerd. I'm not sure if it's the same thing. You'd have to go check. You think you're some kind of hotshot, do you? Using RCC, oh, willy-nilly. Oh, it says as well as a 94-inch monolithic lightweight compartment. Yeah. Well, I'd assume that they, 3D printed main injector and main combustion chamber, as well as a carbon composite nozzle. Why is that a big deal? Well, okay. No, Iron, don't worry about it. No. There's no stupid questions as long as you're like actually asking me a question. You know what I mean? So RCC. So reinforced carbon-carbon. So anytime you hear me say RCC, that's what I mean. That's what they made here. That's what they made the space shuttle nose cone out of. RCC. Here, take a look at Endeavour. Oh, hey Endeavour. Boop, boop the snoot. See this thing right here, this gray? RCC can straight up resist re-entry heating. Non-ablative. No ablation, no nothing. You know, you see like ships in Star Wars, right? Ships in Star Wars, they come back down, they can go through re-entry, no problem. It's really not a big deal, right? Reinforced carbon-carbon is like that. It is like, it's really hard to make, but it can straight up resist. Like the tiles, it can straight up resist the heat. It's devised from nuclear warheads, to be honest with you, but this straight up resists the heat. It can withstand insane amounts of heat, and it keeps heat away from whatever it's leading on, right? So if you make a nozzle for a rocket engine out of this, you won't have to worry about cooling the nozzle. It'll be able to take the heat, which is really, really cool. Or is it hot? Now, why is that a big deal? What's the big deal out of that? Well, if you're making the nozzle out of carbon-carbon, and provided that I'm reading that sentence correctly, could be reading it wrong, if they figured out a way to 3D print RCC, that's a big deal. That's really, 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 really cutting edge stuff. Because 3D printing RCC like that could lead to making heat shields down the road that straight up resist re-entry heat. It doesn't matter. You could just put a bunch of RCC tiles on your vehicle, plop right through, no problem. It's carbon-carbon composite, dog meat. Yeah, it's better than ceramic. The nose cone on the shuttle got to like 2000 C, guys, like right in this area right here. You could see the scorch marks. See all this? See these white scratches? Plasma scoring. Seriously, it's plasma scoring. That's what all this is. Oh, those shots, too precise to be sand people. Only Imperial stormtroopers are that accurate. Man, sand people must really suck at shooting if stormtroopers are more accurate, huh? Anybody ever consider that? Could a carbon-carbon engine withstand re-entry? It has to be the right shape, Snow. It has to be the right shape, you know? But yeah, sure. If you made it the right shape, yeah, probably. Is RCC heavy? No, Jockey. It's very, very light. Very, very light. Yeah. See that? So if they're making, oh, hey baby. Yes. If they're making nozzles out of RCC, well, that's actually really cool. Yeah, because RCC straight up resists the heat. Like, you just get a little bit of scoring on it, but you get scoring anywhere. Just imagine an RCC inflatable heat shield. Well, inflatable. Probably wouldn't happen that way, but yeah. Anyway, that's actually really cool. Let's see. Let's finish reading this. The specific impulsor ISP of the RL-10CX is 461 seconds, which puts it near the very top of the RL-10 engine family in terms of performance. Yeah, ISP is similar to gas mileage. Specific impulse measures the amount of thrust generated by a rocket engine per unit of propellant consumed per second. Yep. Why does it look like the nose has a hatch? It doesn't. A hatch? These are just other strips of RCC around the nose cone, dude. There's no hatch here. On the top. That right there, that's for the RCS. Alright, let's look at this picture of Atlantis. So, the space shuttle had interchangeable service modules. So the idea was this piece comes off as in one subassembly. You take the whole front RCS off, and the idea is that the space shuttle, if it flies, right, you could refuel the space shuttle components separately, right? So a space shuttle's off doing a mission, it comes back down, right? and one of these things fully fueled is ready to go. So they take the empty RCS tanks off in one big piece, put the full one on, then the shuttle's ready to go. The same thing with the it's the same thing with the OMS pods. See the orbiter maneuvering system pods down here? 1, 2. Those things can just pop off in one subassembly. Yeah. It's like a battery. Detachable fuel tank. Detachable fuel tank. Yep, this whole thing can just pop off. Yep, you pull that whole thing off. Mm-hmm. Here, I'll show you. We'll get a shot of it. Yeah, see? Comes off in one big piece. It looks like that. And there it is in space. And you can see there's points where you hoist it off, right? You can pick this thing right up, detach a couple of wires, like a quick disconnect. So, like I said, the idea is that when the shuttle was up in space, right, and there's an OMS pod that's detached. When the shuttle is up in space, you have a spare pair of these, right? And you fuel them when they're on the ground, right? And then when the shuttle comes back down, you take the old ones off, you put the fueled ones on, and you can turn the shuttle around really quickly. Fun fact, the body flap on the shuttle is interchangeable as well. This piece down here, interchangeable. Yeah, it's all quick disconnect. The idea is it's like an airplane. You can perform maintenance on it very easily. At least that's what they wanted to do. Yeah, see? It can all come apart real easily. There's a forward RCS section. They'd send these things off to fueling. Those OMS pods would make pretty good service modules. Wait a second, that kind of happened, but in reverse. With what the Apollo SM was and how the similar plumbing to an OMS pod. What do you think that is? Those tanks look awfully familiar, don't they? And before people say, oh, that's ATV derived. Yeah, it's ATV derived, but it's got shuttle OMS parts shoehorned into the back. Absolutely. Yeah, even the engine. That's a shuttle AJ-10 engine, an AJ-10 190 from the shuttles. They reused them. Can you give one a stir? Nah, I'm good. No, we good. Yep. So, you're not that far off, dude. Yeah. The ESM is basically taking an ATV's reaction control system and combining them with the shuttle OMS pod. Yep. The tanks, like I said, tanks look awfully familiar, don't they? See? They look almost exactly the same. Same size, same everything. They're probably not the exact tanks. They probably made new tanks, to be honest, but the design is derived from it. AJ-10s are amazing. What's their specific impulse? Their specific impulse is relatively low. It's not that high. But yeah, there's the detachable parts right there. I'm more referring to the domestic service module from the Constellation program. Yeah, that would have been nice, wouldn't it? That would have been nice. But yeah, pretty cool. The RL-10CX is designed, fabricated, assembled, and tested at Aerojet Rocketdyne's facility located in West Palm Beach. Really? West Palm? Not Canoga Park? Shame. Oh, they're in Jupiter, okay. Oh, look at this. Huh. That is a big rocket area to build rocket motors. That's nice. I wonder what that is. Hang on. Middle mouse button isn't working on the mouse. It's because dust is getting jammed up in there. There we go. Hey, what is this? Oh, yep, there we go. Vacuum testing chamber right there. See the pipe coming out? Interesting. I wonder if they tested them there. Wow, look at all this. Whoa, whoa, hey. Hey. Look at, there's a bunch of test stands out here in West Palm Beach. I never knew about these. Oh, yeah. Oh, yeah. Yeah. This is all rocket testing paraphernalia here. I don't know what it's for, to be honest, fellas. What is all this out here? Wow, is that out in the... Ah, interesting. It's for rockets, obviously. Dude. Now we're talking. What do we got here? A little road course? A little road course and a drag strip right there? Hell yeah. Hell yeah. Build some rocket engines, go down the street, drag race some cars. Nice. Yeah, bud. Freaking mint. Yeah, I didn't realize that there's that big of a test area down here. There is, though. Wait a minute. Thomas, are you still here? Where is the Aerojet 260? Oh yeah, okay. It's a little ways away. Well, there was rocket test stands here at one point. Not anymore, though. Road course to test the rovers. Hell yeah. There it is. There's the Castor 260. That's just a shame. The biggest SRB ever designed is in there. They used it once and then the project got defunded. Shame. They wouldn't make much power, Synerd, but they'd be very efficient. But yeah, I was wondering if that's near it, but it's not. That's way up there. Cool. All right, neat. That's what I wanted to know. All right, next bit of space news. Well, we already kind of covered that, so team is right on schedule with the L-1 day briefing for the wet dress rehearsal. It should be done by tomorrow, hopefully. Okay, what is this? NASA Kennedy Space Center. When NASA's Artemis astronauts leave their crew quarters for the lunar missions, they will ride to Launch Complex 39B in a new fleet of futuristic crew transportation vehicles provided by Canoe Technologies. Ah, yes. I, too, want to be transported to the pad in a toaster. I don't know if Lycan, we'd have to go look. So, apparently this was one of the bids submitted for a new crew transportation vehicle to the pad. Oxcart Assembly team is incredibly honored that our team, OA, Hoonigan, Airstream, IBM, and Red Hat proposal for a NASA crew transportation vehicle was a finalist in the award process. At the end of the day, it came down to $11.45 price differential. So Oxcart with Hoonigans, Airstream, IBM, and Red Hat wanted to make that? They wanted to make that? And we got a goddamn toaster oven instead? Together, we developed a concept that we were confident paid homage to the storied history of transporting astronauts to the pad on their first leg of their journey to the cosmos, while at the same time ushering in a new era of technology and innovation. It's an Airstream. It's an Airstream with the overlanding tires. That's so damn cool. Oh, that's so cool. Oh, come on, man. Come on. Oh, no. That is so cool. Oh. I might be a little bit biased here. But you should have done that. That's way freaking cooler. Instead, we got these toasters. Oh! It's not an EV, though. Hold on. For several years, Oxcart Assembly and the Hoonigans have been investing our collective design thinking about the idea of bringing an Airstream concept for crew transport that incorporates EV technology and focus on sustainability and reusability. It is EV! Oh, that's so cool! Oh, that is so freaking cool. I want it. 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 What the frick, dude? Oh, that's so cool! It's probably a training base, Flykin, if I had to guess. Bro. Yo, the Airstream windows would have been TV screens. Did you call the Hoonigan guys and find out if there's a prototype? Oh, I want it. I want one. I want one. That's so cool. But pod car. What is this? What is this? This is the guy. This is what won the con. Yep. Interior is kind of cool. This guy doesn't work. His pants ain't even dirty. It's a joke. I'll admit, I kind of like the panel van, but it's a toaster. Tell a lot about a man by his hands. Yeah, pants that look at mine. No, actually, my hands aren't very dirty right now, but Look at it from that side. See? Oh yeah. Nope. Definitely ain't smooth right here, you know what I'm saying? It's basically this. Toyota's pod concept. Ugh. Oh. They also have a pickup truck. Okay. As much as I hate saying it, that's actually kind of cool. That's cool. That's old Chevy step van style. That's actually really neat. You can, and look, extendable pickup bed. That's kind of cool. All right, that's kind of cool. I like that. That's kind of neat. I hate that it looks like a frigging toaster. Let me see. What's this one? Multi-purpose delivery. That's cool. See, I like this. That's fine. That's cool. That's okay. You know why? Because it doesn't look like a toaster. Yeah, I don't mind that. That's pretty neat. Cyber van, pretty much. I don't mind the pickup truck. Can we like take that and put that front on it? Can we do that? It's not a toaster, but it's a bread box. That doesn't look bad. I don't mind that. The other one, though, that just... What? I like the pickup bed. I'm not gonna lie. I like the pickup bed. That's actually cool. An extendable tailgate to make the box longer. That's actually really smart. That's really cool. But the front, though, not into it. That's kind of cool. The interiors they got right. That's pretty neat. That's so right there is probably why NASA went with this, because it's spacious in there, so you can walk around in a spacesuit. Yeah, I guess I kind of get it. It's just their vehicles all use the same skateboard, which houses motors, battery pack, and such. The steering wheel is only connected by a few wires, and it uses their drive-by-wire system. Hey, Shahad, what's up? No, don't worry about the repost, dude. It's fine. Just got back to CA from the F1 race in Melbourne. So much fun. You were at the F1 race? Oh, man. That's cool. That's awesome, Shahad. Hell yeah. I mean, I can't say that I hate the result. What is people's obsession with a yoke? I don't know. Hope you got your steering angle right. Or not steering angle. Hope you got the lock angle is less than 180 degrees. You're going to have a bad day. I like the pickup truck. The pickup truck doesn't look bad. But then again, that's just because I like pickup trucks. But I like the van the best. These things look like toasters. That looks awesome. That is cool. I like the Airstream a lot. So NASA's buying these for Artemis. That seems to be the case. Yeah. Okay, I kind of get it. I kind of get it. I don't like it, but I kind of get it. That's actually pretty neat. Yeah, that'll look pretty cool. That'll look pretty neat. I mean, honestly, I don't know why they just... I mean, you should just use a Tesla. They're already there. But also, it's a toaster. It's a toaster oven with wheels. I appreciate the design. I really do. I'm not trying to hate, but it's a toaster oven. Teslas aren't nice to work on, though. Well, astronauts get Corvettes. Yeah, I wish. I like the interior. I'm not going to lie to you. I like the interior. I think that's cool. It's to go with their amazing-looking Airbus helicopters. Great choices. Don't get me started, man. I just go off. It looks like a toaster oven sequel. Oh yeah, no, Signer, you know how I feel about rights repair, right? Yeah, so like, can we just take the van front? Can we just take that? Can we just take that and put the pickup bed on the back? That would look cool. I still think that the Hoonigan Airstream is way cooler. That is so legit, dude. But I get it, you know, we got to go with the new hotness. I mean, personally, you wanted the most low-cost solution. You should just go get the shuttle transporters out of the garage and just use those. Those are still cool. But yeah, I mean, I see the canoe, I guess. Like, let me see. Let's read the thread. How many billions of dollars are we going to spend on this? How is this awarded? I hope we picked better contractors than the ML. Oh, wow. Yeah, because building. Okay. Yeah, you know what? You know what? Change the plans. Not reading the thread. Yeah, change the plans. Change the plans. The entire contract is like 150K. Yep, like I said, guys, watch out for that Dunning-Kruger curve. It's a real doozy. Actually, you know what? I got a question, fellas. If you guys... okay, say you're in NASA's position. You want something futuristic, right? What would you choose to move the astronauts to the pad? You want something super futuristic, right? What would you choose? Teslas? Cybertrucks? I mean, honestly, the Model X is really not a bad idea because of the gull-wing doors. You can get more in. That's actually pretty smart, dude. Cybertruck? Not that. Not the toaster. Something retro. A Ford Pinto. I would just build an underground tram, e-scooters, teleportation, Cybertrucks, bikes. I wouldn't bikes. No. DeLoreans would be cool. The Hoonigan van, yeah. VW bus, Airstream, Cadillac, good man. Pontiac Aztec, futuristic Corvettes, make them walk. Transport. The Apollo transfer vehicle. Yep. A smart car. Remember, it needs to be spacious enough to fit them in their spacesuits. I did, Mason. I did know that. Project Binky. Good call. The point that I'm trying to get at is that, is there any electric vehicle out there that isn't Tesla that's big enough to, like, move these things? Like, big enough to move a suit around. I mean... Pick them up in the crawler. Good man. What about a lunar rover? Yeah. Like an F-150 Lightning would not have been the worst choice. That actually would have been a pretty good idea. A few Mercedes EQS would be baller. Yeah. An F-150 Lightning, I think. Like, if I was not going to choose the toaster, I would choose a Lightning. Hell yeah. Because it's not like you're going to have a shortage of parts. It's an F-150. The Hummer EV? Dude, I would choose that. That would be really cool, actually. No, Hellfish, I'm good. The acceleration comes later. Ford has EV transit vans. Not a bad idea. That thing weighs over 9,000 pounds. Yeah. How about that F-150 retro EV truck? That'd be kind of cool. But yeah, interesting. Interesting. I don't know. I'm still privy to the, you know... the old, the shuttle transport vehicle. I still think that looks cool. So what they use during the shuttle program is this bad boy. I still think that looks neat, to be honest with you. I think that's really freaking cool. Is NASA still doing this? The space exploration vehicle? No. That was part of Constellation. It really is a toaster, yeah. That's why that's why the Hoonigan concept wins for you, yeah. Whatever it is, I wouldn't want it to be there just because it's a cheaper option. Really hope there was more to the decision than the cost. I thought the Airstream always looked good, man, to be honest. That looks awesome. It still looks space age. To this day, it looks like Starship. Just EV swap that. That's basically what Hoonigan's concept was. EV swapped Airstream. And then, you know, Airstream can benefit because they get research and development on making electric motorhomes. No, instead we got a toaster. Don't get me wrong, some of those canoe trucks look actually pretty damn cool. I will say, some of them look pretty neat. But Tesla would be the obvious answer there. But, you know, we can't do that. Not sure if you saw this, but... yeah, I saw it. It's pretty neat, Creeper. Yeah. You guys got to remember, the whole reason they have that big crew transport vehicle is because it was designed to carry 7 astronauts. That's why they had a big one. Orion only needs 4. So you can do something smaller. But I still say 2 Model X's would probably be a good idea, but... I just hope they're actually producing the canoes right now, because nobody likes it when you choose a bidder and they can't deliver. It's happened to NASA a few times. That's happened to NASA plenty of times, Synerd. Yeah. Yeah, it's happened many times, actually. EV Humvees is what I would probably end up choosing, despite it being GM. I don't care. I think that would be neat. Or an F-150 Lightning. The F-150 Lightnings would be cool. What about a monorail? Monorail. In my opinion, they really wanted a futuristic thing that would actually be available. Cybertruck. Yep. I think the canoe delivery van would look cooler as an Astro van. The canoe, the canoe work truck the work van was cool. What was the name of that thing? It's this one, and not the toasters. I think the toasters look ridiculous. I'm only borrowing your Humvee. Let's see. Multi-purpose vehicle. I like this. I think that's cool.
It's not done by one person, right? It's a team.
We'll have a conversation about one small little area. I need, 3 millimeters in this area. We can give you 2, and we're fighting for every single millimeter in every single area of the vehicle because it's that attention to detail that allows the vehicle to work.
Shift anything by, a few millimeters. It's a lot of back and forth to make sure it's gonna all work together.
This vehicle is using very little traditional automotive stuff, taking a technological approach to building a car.
Every part has a purpose. Driving and engineering, exterior designer,
Electronic control units.
the over-the-air updates,
Manufacturing for interior design.
doors. There's so many parts to this.
The design here is from the inside out. Most people design from the outside in, and then they worry about what's the drivetrain, what's the power plant. We were driving this thing when it was just a chassis.
They don't do that. That's not how cars are designed at all.
The skateboard concept was continuous from the start. The integration of the battery, the drive unit, the communication between the two, the steering, etc. Everything that you need to drive the vehicle is essentially in the skateboard.
So there's no physical link there. As long as you have a wire to it, you can literally put that steering wheel anywhere.
What that means is you can then move the driver with whatever top hat makes the most sense.
The top hat, it is the interior of the vehicle, it's the exterior of the vehicle, it's the shape of the outside.
That's cool. I like the modular design. I think that's really neat. But also, it's a toaster.
Really, there's endless possibilities when it comes to that. So whether you have a lifestyle vehicle that we're working on, or a delivery van, a sports vehicle, a sedan, a pickup truck, there's a lot of different options that can come with it.
If the platform enables you to do like a most open space ever, why won't you do that? This is the main story, freedom of creativity that a platform enables.
Canoe is making it easily accessible for everybody to get an electric vehicle.
Changing the way the world thinks about cars.
Like anybody who innovates, you don't want to be inhibited. And that's where the heart of innovation happens. Those people that want to break the rules.
Most EVs are.
We wanted to
2020,
build
yeah.
a vehicle that would last and make a difference, because the world is mobile. And when you can do it ecologically, it becomes more mobile. We're going to help people have a better life. This is meaningful.
Not to throw a monkey wrench in that, but literally every vehicle is designed from the ground, from the inside out. Like literally every vehicle. It's been done like that since like the 30s. Not to be a dick, like I don't know what you're getting at. Like literally, body on chassis design has existed for 100 years. Body on chassis implies building from the inside out, because you're putting the body on a chassis, meaning you design the chassis first. But it sounds good to investors. Yeah, it's marketing. I understand. I like the idea of it though. I mean, yeah, RJ, it's like, okay, I mean, it's clearly saw some prototypes there. Let me see, look, hang on, let me zap this. So the girl's talking there about, come on. An aluminum space frame, from what I can tell. Okay. You can put anything you drop it at once, so we picked the toaster. So, interesting thing here. It looks like some of these parts are stamped, which means that they have an assembly line of some sort up. See these parts? That's all stamped. Stamped and spot welded. And then in a little bit of a later thing, I saw some seam sealer on those spot welds, but yeah, interesting. Wait, why can't you do that one? That one that doesn't look like a toaster. Nope, it's gotta be a toaster. Headroom, yeah. Interesting. That's okay. I can't see that picture. 619. Know it's very odd that they didn't show any large manufacturing machinery. Yeah, I didn't see much either. I saw a paint booth and a design booth. Yeah. There's another episode. Interesting. Interesting. I mean, I like that multi-purpose delivery vehicle. I think that's a cool idea. Yeah, let's see. Let's see what this video is about.
No one really thinks of the small guy. No one thinks of the everyday hustler. Why not take care of those that are working on the ground every single day? To think of people's livelihood and their wellness as you design things, it's huge.
This is a car, sir.
I always try to look for a way to find a bridge between new and old. If you look at Kogi and our company, we're kind of low tech on one end. We're very in-person, we show up to the neighborhood, but we're spreading our information at the speed of light. I find something like this to be a bridge. It can create community.
I find it to be a bridge. Literally shows a picture of a bridge.
It has the ability to show up, you know, and be there for you. If this company was just a fancy electric car company, you know, that was selling tricked out $300,000 electric vehicles, I'd be like, cool, live your life. But the fact that it is designed and priced for the everyday person, you get like little hints about stuff in life. And for me, that was like, okay, maybe this is something. If you start to care about the masses and not just the few, that's going to switch the balance of power. And it's going to make everyone have a little bit of a better life.
What? All right. Okay. It's a truck. Like, I'm not gonna sit here and say that cars won't save your soul. Cars make me happy, but at the end of the day, even me, somebody that loves freaking cars, I know it's just metal and rubber. It's not a truck. It's a canoe. Huh. All right. I don't know, Mason. I don't know. Why do English people call it a suicide door and then use it in that toaster? I don't know, man. I don't know. What's that, 619? Oh boy, I was wondering when somebody would link this. All right, well, I guess we shouldn't hate on Canoe too much. Let's see what they can come up with. All right. And okay, here's the last thing for space news. 619, I was wondering when somebody was going to link this. Thomas, we can watch the capabilities video later. I mean, it's kind of neat. I think it's cool. I like the modular concept. That's really neat. But once again, body on chassis design is not anything new. I said no, I want you to break this down. You want me to break down that? We should all get the same answer, folks. Imagine a 747 is sitting on a conveyor belt as wide and as long as the runway. Okay, so we have a conveyor belt that's like 9,000 feet long. Got it. The conveyor belt is designed to exactly match the speed of the wheels moving in the opposite direction. Can the plane take off? No. 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 No, not at all. You have no airspeed. You have no airspeed. You have ground speed, but you have relative ground speed. You have no airspeed. Let me guess. This Twitter thread is a freaking nightmare, isn't it? You have no airspeed, dudes. Yes, if you have a huge headwind. It's not a car. With a 200-mile-an-hour headwind, Mythbusters did this. Read it again. Imagine a 747 is sitting on a conveyor belt as wide and as long as a runway. The conveyor belt is designed to exactly match the speed of the wheels moving in the opposite direction. Meaning if the plane starts moving forward, the conveyor belt starts moving backward, right? That means the plane stands still. Yes, you have airspeed because the wheels can rotate as fast as possible, but they don't provide power or push. Oh, nice, Creeper. 52 years, yeah, Apollo 13, nice. You missed the point of the question. Aircraft will fall off of the treadmill. The jet forward motion is based on the jets, not the wheels. Technically, yes, you would continue down the runway unless the drag... If the engines push the plane through the air at takeoff speed, it doesn't matter how fast the wheels are spinning. Driving force, you all say the driving force is not in the wheels. I understand that. Night, Sun Temple, I'll see you later. Your wheels would reach infinite acceleration. The plane will still move forward on the treadmill. But you need... All I'm going to say is Mythbusters did this myth and already the plane already took off. Yeah, but... I understand the wheels aren't connected. Hang on. You need to get airspeed. So how do you get airspeed, right? So this is clearly a logic trap question. So I may have been wrong. Let's see. So I don't give a frick what the Mythbusters did. That's whatever. I don't care. So conveyor belt moves backwards, wheels go forward. The plane, if the plane starts moving forward... Yeah, I get it. The wheels aren't connected to drive, so you will eventually get airspeed, but it'll... That's very strange. You get airspeed through the jet engines pushing the plane through the air. The 747 needs 150 knots of airspeed to take off. It sits stationary at runway and 150 knot headwind. Can it take off? Wheel speed is 0 in this case. Yeah, of course it can, Tech. Yeah. Okay, I get it. Wheel drag is the only extra force here, and it's not enough to worry about at all. But the RPMs on the wheels should theoretically be double then, right? The RPMs on the wheels would be higher. What if you're going down the runway and you blow a tire? That would suck. You ain't going nowhere. Yeah, I get it. I get it. So it's not... Yeah, you can get airspeed still because the wheels... Yeah, the wheels are free spinning. Yeah, okay, I got you. The belt will match the speed of the wheels is a fundamentally false statement from the start. Yeah, Bill. Because if it's going to match the exact speed, that means any forward. Yeah, the wheels will spin at twice the RPM. That's a pretty crappily worded question, don't you think? It's like intentionally misleading. But yeah, I guess that's kind of the point, you know? Hey, Lemons, what's going on? There's a special guest on the NSF stream. Cool, cool. Also, the wheel RPM or structure isn't a factor here. Yeah, Swishio, you say that, but the question acts like it is, which it's not. That's the trick. I get it. Yeah. You gotta have airspeed. The wheels don't matter. It's about air moving over the wings. Salary 51-month resub. Yeah. And that, yeah, I mean, so I used the wrong formula, but I got the right answer. No. You need airspeed. That's the thing. The wheels don't matter. It doesn't matter. But see, the conveyor belt designed to exactly match the speed of the wheels moving in the opposite direction, right? Like, yeah, I mean, it shouldn't theoretically make that big of a difference, but that's certainly, see, okay, all right, we really want to be technical here. When the plane starts going down the runway, so right when you put the engines up, it would take the plane a lot longer to get up to airspeed, right? Because the conveyor belt's moving backwards at the same speed as the wheels. So theoretically, this is going to take a little bit longer to get up to airspeed, but you still should be able to take off. It won't take too long for the jet engines to overcome that, the conveyor belt going in the wrong direction. But your wheels are going to start moving real quick, real fast. In this particular scenario, I get what they're trying to say. It's a very generalized question, but you're going to exceed maximum theoretical RPM on your wheels real quick. They'll probably explode. Yeah, they'll probably pop. The friction on the wheels would cause something. The wheels would accelerate and break off. Yeah. Or as in this particular, like I said, plane will still take off, but at what cost? The wheels. So, all right, here. The plane will still take off, right? And that's the premise of the question. But you want to break the engineering down. Check this out. So, the wheels are rated for a theoretical maximum RPM. Tires, when they start spinning too fast, what they start to do is they start to stretch. And when they start to stretch, the bead of the tire will, because they're spinning so fast, the bead of the tire will start to compress. And the wheel, you'll blow a tire eventually. They'll depressurize because the bead is no longer on the outside of the rim, so they'll go in like this, right? And the wheel will pop. So, honestly, the question here, right? Will it take off? With a practical understanding of physics, yeah, sure. Of course it will. But in real life, what would probably happen is, one, you're going to need a runway that's a little bit longer than a regular runway. I hope it's a 9,000-foot runway. B, how much cargo does the 747 have? Because you're going to need a longer runway regardless. C, I hope we don't exceed operating speed on those wheels, because if we exceed operating speed, the tires will pop. And if the tires pop when you're going down the runway, if you hit V1 and then a tire pops, you're not going to have a good day. 165 knots max wheel speed is standard for most aircraft tires. And you will exceed that. You will exceed that with this. Oh, easily. Yeah, with practical physics, yeah, the plane will take off because you need airspeed. So I said no with an asterisk next to it. That's not right. So it will take off. I get it. I understand why. It'll take off. But also, your tires are going to be spinning at a way higher relative speed. The tires, by the time you hit V1 and you rotate, they're going to be spinning twice as fast, easily twice as fast. Am I wrong in this? Last time I checked, an F1 car doesn't take off in a wind tunnel. That's airspeed, RB, not ground speed. Here, rocket guy, look. Oh boy. Rocket guy, Physics us so we can learn. You factor in air resistance between the conveyor belt and the air above it. The plane will actually take off in less runway length than normal due to the conveyor belt basically making a headwind for the plane. I was gonna say, if you put Tech, if you put like here, if the conveyor belt was designed to do some Magnus effect stuff, so if you had a conveyor belt like this, right, and you had this, you had little fins on the top that kind of look like this, right? Something like that. You had fins on the top like that. Oh yeah. Then it works like a big turbine blade. That'll shoot air this way and the plane could take off in place. You could. That'll definitely make it work. You will get some airspeed acceleration from the conveyor belt. You're right, but I honestly think you'd pop a tire. Like if we had this experiment with the 747, the tire will explode. Because even if you take off at a lesser distance, your tire RPM is still going to be twice the relative RPM of a regular tire. I don't think those things are designed for 200% of their rated RPM. Well, but then again, it depends on the safety factor of the RPMs on the wheels. Oh, interesting. Well, it depends on the semantics of the problem. If it exactly matches wheel rotation without delay, you cannot take off. However, if the question instead means it will match the ground speed of the plane to keep the ground speed 0, then yes, it will take off. But your wheels would essentially spin at twice their normal rotation. Yeah, there you go. Right, yeah, that. I said it in a little stupider way than that, but yeah, pretty much. The conveyor matches wheel speed, so in an alternative world, you could just hold the brakes and let the conveyor belt do all the moving for the plane. And have 150 knot airspeed, 150 knot conveyor belt speed. What? No, wait. Which way is the conveyor belt rotating for you? It's designed to exactly match the speed of the wheels. So if the wheels are going this way, that means the conveyor belt's going this way. It's going backwards. Which way do you think the conveyor belt is going, Tech? What if you decide to spin your wheels backwards then? I suppose if you put the thrust reverser on, it'll, yeah, sure, it'll get. That's funny, man. The key at the end of the day, no matter what conclusion you guys come to, is airspeed. Airspeed is the key here. It doesn't matter how fast the wheels are moving. It doesn't matter how fast the ground is moving. It matters how fast the air is moving. That's the key. There's zero airspeed. Yeah, but engine RPMs, so here's the trick. Engine RPM, so basically it would be your N2 fan speed, right? You could basically create more thrust because your drive isn't connected directly to the wheels. So if you can create more thrust to overcome the opposite force of those wheels, so basically, like people said in chat, the wheel friction, yeah, I get it. But see, here's the thing. Even the engine's moving down, even the engine's pushing against the wheels. All right, the engines create that thrust, and that thrust will create the airspeed to go over the wings. I mean, you're forcing the thing forward, you get more relative airspeed, which is why I think that honestly, in this scenario, I think the 747 wheels would fail. The trucks would overheat. You'd blow up the landing gear. The landing gear would explode before you took off. But yeah, it's all about airspeed, guys. That's what matters. You'd literally fry the landing gear. You're very confused. Physics do be like that, though. Yeah, you keep saying, oh, what about an airboat? What about airboats don't have wheels. They don't have wheels. So that's kind of not how it works. Airboats don't have wheels. They have boat. And you're on a different surface, you know? Maybe I'm pretty stupid. Solar, basically the engines will overcome the RPMs of the wheels eventually. That's all. But like I said, you'll exceed RPM on those wheels. The bearings and the tires will basically destroy themselves before you even take off. That's my theory, but I don't know. You know, people are gonna be like, oh, the Mythbusters tested this. You know, it's not a 747, man. Are you saying airflow will be caused by the engine exhaust despite 0 ground speed? Yes. Yeah, of course. Call it in high enough winds, a plane can just take off. Think about like an aircraft carrier, okay? An aircraft carrier will turn into the wind, headwind. You'll get a headwind. It's all about airspeed moving over the plane. Ground speed means dick when it comes to airplanes. That means nothing. I mean, it doesn't mean nothing exactly, but you can have airspeed. So like airspeed over the wings is the biggest deal. So the carrier turns into the headwind, right? And say you're not using a catapult or something. Say it's a World War II carrier, right? And you have a plane that has no bombs on it or anything that starts rolling down the runway on the aircraft carrier. If you have a good enough headwind, that plane will look like it just rises up into the air. There's footage of this all over the place. It's all about the airspeed over the wings, guys. The wheels are kind of irrelevant. But see, I think where people are getting confused is the wheels. You know, oh, the conveyor belt matches the wheels, so the plane stays in one spot. Well, the engines can overpower the wheels. But it would take a second. I honestly think it would take a second. The engines can overpower the lack of wheels, too. That's probably a better way to look at it, Psynerd. Basically, the jet engines are powerful enough to overcome the speed of the wheels. But what I'm saying is like you would need a longer runway, and you're doubling your wheel speed. You're doubling the wheel speed. So as long as you have airspeed, yeah, it'll take off. But the engines would have to overcome. They would have to. You know, people say, oh, it's working against the wheels. The wheels, yeah, there's still friction. There's still rolling resistance with an airplane. It's low, but it's there. So you wouldn't need like a runway that's like double the length, right? But you would need a runway that's a little bit longer. Because honestly, your rolling resistance is getting screwed right there. So it wouldn't need to be much longer, but it would be longer. But for that, like, say 125% long runway, say you had it, say, you know, the conveyor belt was 9,000 feet. Right? You'd get to the end of the conveyor belt. Well, you wouldn't get to the end of the conveyor belt. It would take a longer distance. What if you take the jet out of it and put turboprops? Would it then change? No. What if the wheels were frictionless? If the wheels are frictionless, it'll just take, it'll just go to the end of the runway, it'll take off. The jet engines can overpower the wheels, guys. As long as the jet engines can push the plane forward enough to create airspeed over the wings, it doesn't matter. Of course it'll take off. But see, it's kind of a misleading question because the conveyor belt is designed to exactly match the speed of the wheels. The plane doesn't have drive going to the wheels. It has brakes and that's it, right? But if the conveyor belt can move fast enough to spin those wheels, if the conveyor belt can move fast enough to spin those wheels, you know, the plane will stay stationary. But I don't think the conveyor belt could spin at a speed where it would negate the thrust of the engines. If anything, it'll take off. It'll take off. I mean, you'll get some Magnus effect from it, definitely. Yeah, I mean, anything that moves through the air is going to move the air around it a little bit, you know. You guys are still talking about this. Well, it takes a second. I mean, it's a logic trap. So at face value, I said no, and that's not right. But I figured out why it's the opposite of that. You know, like It's a hypothetical conveyor that will keep the plane stationary with respect to the ground. It won't take off. Is this Twitter thread, is the Twitter thread as bad as the question, is as bad as the chat is? Again, the question is poorly worded. It is in semantics in terms of what is meant by exactly matching the wheel speed. After acceleration, the wheel speed after acceleration, those are the key. If the treadmill matches the rotation in the instance of the wheels rolling, it won't take off. But if instead the question is referring to negating ground speed by matching the wheel speed after acceleration, it can take off. Yeah, Rocket Guy, yeah, like I said, it's a little bit misleading. Yeah. Would the conveyor create a ground effect? Sure, Mutter. You'd get Magnus effect from it. Absolutely. Sure. Yeah, if the conveyor belt was spinning fast enough, dude, you'd get a vacuum. It would accelerate the air. But if the conveyor belt had little, like, fins on it, or the conveyor belt was,
Discovery, go at throttle up.
If the conveyor belt was like a golf ball, like a dimpled surface, Mutter, you would create, you could create a lot of airspeed. You could do it. It's possible. But, Mutter, what would happen is the ground effect would start happening because you'd be compressing air underneath the wings, right? And then the plane would go to take off, and then it would just come back down. It would porpoise, believe it or not, like a Formula 1 car. Formula 1 car in this scenario, like the Formula 1 car's porpoising is the conveyor belt, and the plane is the ground, so to speak. You'd flip it upside down. The thing would do this. Yeah, Rocket Guy, I think in context of this, what they're asking, what the question is trying to get at, because, everybody, the Mythbusters tested it. What they're trying to get at is that I think the way the question is worded, the plane can overcome the RPM of the wheels with the jet engines, right? So it can out accelerate the conveyor belt, and if it can out accelerate the conveyor belt, it'll take off. But once again, if the conveyor belt is designed to negate the movement of the plane by matching the wheel speed, people are going to say, the wheels don't move. Yeah, well, you're still getting friction. You're still getting rolling resistance on the wheels. If the conveyor belt can compensate for the rolling resistance, then no, it's not going to take off because you're not going to get any airspeed. If you scroll down, it's like 99% no. Well, once again, engineering is more complicated than ones and zeros, O-Force. The way I interpreted this question is that the conveyor belt is designed to the conveyor belt can overcome the acceleration that's from the jet engines. And if it can overcome the accelerations, then the plane ain't going to move. It's not going to take off. But if the jet engines can overcome the conveyor belt, then it will take off. Sure. I wouldn't trust 90% of the people on Twitter. Maybe this plane can. The YC-14? Why would a YC-14 be able to do that? Yeah, that's a nice conveyor belt iron for sure. It is no, unless the conveyor belt just matches the takeoff ground speed. That's it. Yeah, I get it. That's what I said. That's what I said. I said if you can't generate airspeed, it doesn't matter what the ground's doing. I mean, this is, dude. Well, hey, World of Engineering wanted to ask this question. They want to drive engagement. They succeeded pretty freaking hard, man. But if the spirit of the question is that nothing allows the plane to move forward, then no. For anyone interested, the YouTube video I posted seems to explain the positions, I think. That looks like Captain Joe. All right, here. Let's see what Captain Joe says. An actual airline pilot. Let's see.
To my channel and to a video about an interesting experiment and an aviation riddle that has been around for quite some time now on the internet. So ready to solve the riddle? Then let's get started.
Let's see what Joe says.
Charlie Heavy, 3-1 left, right Alpha, short of Juliet. Confirm they sent you the score 3 departure with the Yankee transition.
Today's video is brought to you by the Captain Joe online shop. Click the link in the description box below to get your Captain Joe 747-8 today. Okay, listen carefully. Now imagine a 747 is sitting on a conveyor belt as wide and as long as a runway.
I agree, Gigan.
The conveyor belt is designed to exactly match the speed of the wheels moving in the opposite direction. Can the plane take off?
Let's see what Joe says.
Pause the video and think about this for a moment. You think you got the answer right, then please share your answer.
Drive that
in the
engagement
comment
right
section.
there.
I am so looking forward to see your answers and explanations, or even share this video with a friend or family member and see what their answer is to this question. Well, if your answer is no, then congratulations, you are right. Now don't leave the video just now if you said yes. Just hold that thought. There is more to this question or riddle. So given this particular scenario, the plane is indeed not able to take off. But the question is why? This riddle in this form is a little tricky. Now because it is the wording of the part that describes the initial condition rather than the mechanics behind it that posed a problem. That means in the end it is just propositional logic. So to take off, the airplane has to accelerate to takeoff speed. Therefore, the pilot pushes the throttle levers forward to increase the thrust. With takeoff thrust being set, the airplane will start to move forward and the wheels will slowly start to spin. Now, mind the wording of the riddle. As soon as the wheels start to spin, the conveyor belt will adapt to the speed of the wheels and will match them exactly, while moving in the opposite direction. Now the conveyor belt is designed to perform this speed adaptation without any delay. And this is where the trouble begins. So to pick up ground speed, hence increase the airspeed to ensure sufficient flow over the wings for them to create lift, the airplane has to move forward relative to the ground, meaning it has to cover a certain distance on the conveyor belt. Now, given the preliminary assumption that the conveyor belt matches exactly the speed of the wheels, it is not possible for the plane to do this. So if the plane were to accelerate, the wheels will start to turn forwards. If they do, the conveyor belt will instantly match their speed, moving backwards. While the airplane is still trying to accelerate, the wheels try to move forwards relative to the ground, therefore trying to turn forwards. If they do, the conveyor belt would instantly match their speed again, moving backwards, and so on and so on. I think you get my point. Once started, this turns out to be an endless cycle in which both the wheels and the conveyor belt would theoretically accelerate until they reach infinite velocity, which is of course physically not possible. So the tricky but physically, mechanically not possible part in this riddle is match exactly the speed of the wheels. But what if we set up our experiment
People are upset about this,
earlier,
man.
but now the conveyor belt is designed to match the ground speed at which the airplane takes off while still moving in the opposite direction. Is the 747 able to take off in this scenario? The correct answer is yes, and interestingly, there is little to no difference in required takeoff power, rotation speed, and length of the takeoff roll compared to a takeoff from a normal runway without the conveyor belt. The reason behind this is on how the plane propels itself, pun intended, forwards, which works differently compared to a car's propulsion. In a car, the engine is hooked up to a gearbox and then via a drive shaft transfers the power onto the wheels and then onto the road. Now let's say we were to place your car on a conveyor belt and you are accelerating to 150 kilometers per hour, but simultaneously the conveyor belt is also turning at 150 kilometers per hour, but in the opposite direction. Your speedometer in your car will show 150, but relative to the ground, you are not moving at all. So let's continue and say the conveyor belt keeps at a constant 150 kilometers, and your aim is now to accelerate to 150 kilometers relative to the ground. Since your engine is already keeping you at the same speed as the conveyor belt, the power your engine must therefore provide equals the power it would need to accelerate you from 150 to 300 kilometers per hour of ground speed. That can only be performed on the German Autobahn, yeah. An airplane, on the other hand, does not accelerate by sending power to its wheels. The wheels of an airplane are not driven, they spin freely. The forward motion occurs because the air passing through the engine
A340, nice plane.
And
in F1 livery.
In the form of a jet, which generates the required thrust to propel ourselves forward. And we've learned all of that from our good old friend Isaac Newton and his third law. So quick breakdown of Newton's third law. Every action or force in nature, there is an equal and opposite reaction. In other words, if object A, in our case the thrust output, exerts a force on object B being our 747, the object B also exerts an equal and opposite force on object A, meaning the 747 moves in the opposite direction of the engine output. That means during takeoff, it does not matter how fast or in what direction the wheels are spinning, because they do not play a role in airplane propulsion. Does that make sense? An easier example might be a propeller-driven plane. A propeller is very basically speaking a screw that is driving itself into or through the air. Even better, think of the propeller of a boat. It's virtually turning itself through the water like a screw would if you drill it into a wall. So it's pulling or pushing the boat. Okay, let's come back to the airplane one more time. Now the wheels in our scenario would simply turn at twice the speed they would turn if the plane were to take off on a normal runway. Keep in mind though, aircraft tires such as the Boeing 747 have a maximum tire speed limit at 206 knots. The plane rotates at about 160 knots. That would mean it would have already exceeded the limit by nearly 100 knots, and that is a no bueno. The only 747 that can do that is the Captain Joe 747
Nice. Hey, did I not just say that? That was a good segue, my guy. So that was Captain Joe on YouTube, guys. See? It's frame of interpretation of the question. So I guess so here's the real truth. Engineering is way more complicated than will it move, will it not move. You have to take into account a lot of different variables. So it could be yes, it could be no, it depends. Cool. Nice. And just as expected, I knew that would take up the last bit of space news. Oh, boy. Yeah, it turns out that engineering is a little more complicated than just will it move, will it not move. Well, it depends. It depends on what's going on there. Yeah, Wolfie, that's what I said. I said, no, it won't move because it's dependent on airspeed. And chat says, oh, well, it can overcome the airspeed. And I'm like, okay, all right, if it can overcome the airspeed, sure, it'll go down the runway conveyor belt, but you'll probably blow the wheels up before you take off. That's exactly what I said. Of course they will, Nils. People won't get over that it's a frame of reference question. If you, like I said, if it's an engineering question, I go very literally. You take it at literal value there, right? You take it at literal value. The plane can't take a, like if the conveyor belt instantly can combat the RPM of the wheels, right? Then you're not going to move, and you can't create airspeed, and you can't take off. But if the plane can overcome the conveyor belt, or if the conveyor belt has some kind of delay or something, it'll take off eventually. You'll probably exceed RPM on the wheels, and the wheels will explode before that happens, but it will do it. Tires are rated for RPM. Airplane tires are rated for much higher RPM than car tires are, but tires are rated for RPM because tires start doing weird things if you exceed their operating RPM.
Discovery, go at throttle up.
So if you said yes, yeah, I mean, I guess you're right. If you said no, you're also kind of right. I took it literally, so I said no, and I'm going to stick with that. But yeah, it depends on frame of reference there. Pretty cool though. Good question. T-Man, oh hi, Block 4 Falcon 9 Core. Oh. Where's that picture coming from? I mean, and if you want to get really technical, yeah, Stoller, if you want to get really technical, what's your tire pressure at? What's your tire pressure at? If it's at high pressure, it'll stay cooler, which means it won't melt. But if you're at low pressure, you're going to blow the tire real fast. I mean, this is everything you got to take into account, man. What's the runway? What's the conveyor belt surface made out of? What's that made out of?
Go at throttle up.
Is it wood? Is it rubber? I don't know. Is rubber on rubber going to give you more or less rolling resistance than if you were rolling down an asphalt runway? So how are you doing? Also nailed the interview. Next week I'll have a follow-up. Cool. Mad Harry Jack, 5-month resub. Thank you very much. Sweet. It doesn't matter since it matches wheel RPM exactly. Well, once again, frame of reference predominant. I shifted it to the wheels. What are we're talking about RPM exceeding the wheels. The wheels exceeding RPM, right? So tire pressure would have a lot to do with that, just like it does when we're racing. I mean, I'm more talking about what point is that wheel going to fail. And that's dependent on a couple of different things, right? Once again, we're in a subset here of that engineering problem. That's the kind of stuff that Joe was talking about at the end of the video. But yeah, I agree. If it matches exactly, I don't think it'll take off. I don't think the plane would be able to overcome the momentum. And once again, the delay on the conveyor belt is the big one there. But yeah, here. Check this out, fellas. Here, let's here, look at this. If you have, this is a bush plane. This is the STOL stuff. Here, look. Watch this. Check this out. If you have a good enough headwind, plane will just take off. You can take off relatively in a really short distance. Look. Whoop. Bye-bye.
This is the STOL, short takeoff and landing competition.
See? If you're going into a headwind, the thing will just go right up off the ground. Because, once again, this is the first thing that I said, airspeed is what makes the difference. If you're taking off into a headwind, you don't need as much of a takeoff distance because it's about the air moving over the wings. The ground has nothing to do with it. If you assume the conveyor is only matching the power-driven wheels and not the speed of them driven by the engines, would the conveyor not move at all or just like a normal runway? I don't know. Props also push air over the wing. Yeah, Erper, kind of, yeah, but see, the thing about the prop, oh, the prop, you say, oh, the prop is accelerating air over the wing. Kind of and no. It is accelerating air over the wings, right? Because the propeller's out in front, right? But the propeller creates a lot of drag. It creates a lot of drag. It's a byproduct of it moving through the air. It creates drag, and that drag going over the wing, especially, actually, if it goes over the wing, it's not that big of a deal. If it's going under the wing, then the wing work doesn't work as well, because you don't want low pressure. You don't want drag underneath the wing. If you get drag underneath the wing, plane won't plane very good. It'll down into the ground. So the propeller doesn't necessarily move, like force air over the wings. There are certain aerodynamic designs that will get you a result that are designed to force like air out over the wings in certain ways. Like an XB70 will do that with compression lift. But yeah, on the whole, no. Having the propeller out in front is pretty bad. Pretty bad for it. And you know what the funny thing is? Having your propeller out the back is also bad. You have to have a very, 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 very... You have to be very careful with where you place the propeller on a plane. For instance, I'll give you an example. Convair B-36. They came up with this idea. Convair came up with this idea of putting the engines in the back. So the B-36... Here, let me show this picture, right? The Convair B-36 has 6 backward-facing propeller engines, right? And you look at the B-29 or B-50. It could be either one. That has forward-facing propeller engines. So the props create a little bit of turbulence and the wings don't work that well behind the props. But guess what? With the B-36, the wing is in the way of the propellers. So your propellers have to work a lot harder because they're dealing with turbulent air. They have dirty air going into the props. The B-36 was notorious at high speed, right? So i.e. the speeds that you need to take off. Having the engines literally catch on fire because the propellers were trying to drive the propellers enough to move the air, right? Yeah, it's dirty air. It's disrupted air. It's non-laminar flow. That fed non-laminar flow into the propellers, and the engines literally would just overheat and light themselves on fire. Yeah, that's why they ended up the B-36 in later variants. Check this out. The B-36 in later variants, what they ended up doing is attaching some jet engines to either side. 2 jet engines. They attached 2 jet engines to either side to give it the performance that it was originally advertised for. Yeah. 6 turning, 4 burning. What about the Shinden? What the hell is a Shinden? I don't know what that is. Well, you know, every time I mention something, people say, well, what about the Porcupine? That plane was a hell of a... I don't know what that is. Shinden. Do I want to Google it? What is it? What? Oh, this thing. Is the wing directly in front of the propeller goalie? You can allow links, you just have to ask, Stoller. Look where the prop is comparatively to the wing. Yeah, that was an advanced Japanese fighter that was in concept when the war ended. See? Look, the propeller has some low pressure going down here, but the prop will work up here. The Germans also did this right with this plane, the Dornier. The Germans figured it out that you don't want the wing. If you have a backward-facing propeller, you really do not want the wing near it. See what I'm talking about? So they basically made the fuselage channel the air into that backward-facing propeller. See that? Yeah, the Dornier. That's the only one in existence. It had a forward and backward-facing jet engine. Yep, push-pull. And that's why there are some Rutan designs. Rutan plane. Burt Rutan has planes with backward-facing propellers. And the funny thing is that it's the same idea. It's the same idea as that J7, the Shinden. Same thing. The propeller is technically underneath or over the wings. See that? And this airframe is designed to vector clean air into the propellers. Yeah, it's pretty advanced engineering. Also Rutan. Yeah, see? Propeller's still mounted up high, so that means most of the propeller is being used to work. Is being used to push. But some of it is getting disrupted in clean air. But if you design your wings in the right way, you can actually accelerate air over the propeller. But the B-36 didn't do that. The engine's just caught on fire, and then, you know, fire on an airplane. That's good. Yeah, no, not good. What would be the advantage? A backwards facing propeller engine? What would be the advantage? Well, it's like that engineering question, dudes. It's what are you trying to do? Like, what are you trying to do? You want to create a plane that can outturn stuff? Yeah, put the engine in the back and put canards on the front. It'll be able to outturn whatever. I can give you a modern example. So if you're trying to create some kind of air superiority fighter, something that can outturn something in a dogfight, you put the engines in the back and you put canards up front. Canards are intended for a result. I don't hate them. I know people are going to say it. They're intended to achieve a certain result. The idea is that the Eurofighter can outturn anything. Stellar, never mind. Too much fan flooding. You have to get perms from one of the moderators. Ask one of my mods. If not, I can give you link perms. But I saw your question. I mean, you whispered a link to me anyway, so... You're talking about spin launch. Yeah, I know about spin launch. Do I think it's going to work? I don't know. It depends. I have no idea. I'm a little skeptical because it seems like a hammer looking for a nail instead of vice versa. But I don't know. I have no idea. Eurofighter is the best from the EU. Depends on how much money you throw at it. Any type of engineering, as long as it's in the confines of practical physics, will work. It's not about what will work and what doesn't work. It's about what are you trying to do? You know? What are you trying to do? I'll give you an example. Could humans build a bridge from... Could we build a bridge from, like, the UK to Iceland to Greenland to Canada? Could we build a road bridge? Sure. Absolutely. Of course we could. No problem. Well, what are you trying to do? Well, the idea about building a road bridge is that you could move a lot of traffic, right? You could move a lot of traffic across that bridge, you know? Trade would be great. You could just drive to Europe. That would be freaking sweet, right? Now, you're taking into account... The bridge would have to float because there's no way you're anchoring it to the ground in some parts of the ocean up there. It's way too deep, so the bridge would have to be a floating design. So how do ships get around it? Now, what about every winter the water flows down because, you know, ice melts, etc., etc. Now the water's going to flow down, it's going to try to flow in the Atlantic. What about currents? The bridge will move back and forth. You have to take into account all this stuff, right? What about tectonic plate shift? What about there's a bunch of things that you have to take into account, right? Do all those things that you have to take into account, does that sound easier than just using a container ship to ship your freight across the Atlantic Ocean? No, a container ship is 1,000 times freaking easier. And they're 1,000 times easier to maintain than a 1,000-mile long bridge that crosses, you know, that island hops across the Atlantic. Well, it wouldn't be 1,000, it'd be like 3,000, but... See what I'm talking about? Could we do it? Sure, absolutely. A container ship is way simpler. Way simpler of a solution. And that's why we use container ships. Just freeze all the water. I mean, I'm not saying you can drive a car to the North Pole, PY, but I'm pretty sure they did that once. Some pokey motoring show or whatever. I don't know. It's from England. Pretty sure they drove a Hilux to the North Pole, right? Think of the drive time. Well, container ships don't go very fast. They can go more than 10, 15 knots. They really don't go very quick. Okay, but then you throw a few tens of billions of dollars at the problem, then trucks will be even cheaper. Yeah, swish-yo. And that's what dude, that's what I mean. You throw money at the problem, anything can be done. Is there simpler or better ways to do it? I don't know. Now, you know, let's dial that back into space news. You know, people say, oh, SLS is not sustainable. All right, compared to what? We don't have a container ship that goes to the moon, you dope. Not you, right? So what are you comparing it to? You're comparing it to nothing. You know? See what I'm talking about? Like, you're going to have to throw money at that problem because there's no alternative. Why use container ships? Just ship it with Starship. Yeah, right. What if it was underground and instead of cars, it's rail, though? That would have to be one deep tunnel, Stuart. We'd have to dig deeper than we've ever dug before. That would be deeper than the Kola borehole. Did you see Tori's tweet? Opinions. Tori Bruno tweets a lot, Zay. You're going to have to be a little more specific than that. Yeah, Kyron. Well, tunnels can survive earthquakes, Solaire. There's the Channel Tunnel. That's fine. You'd have to be careful about crossing a tectonic plate with a tunnel. What's that one, Zay? What do we got? Well, let's see. Let's do one last bit of space news, and then we'll play a couple hours of Summer Car. Who's in? Let's see what we got here. Massive Centaur 5. Okay, look, the RL-10 is a great engine, but it is by no means close to the best possible for an upper stage. For one, its low thrust increases grav losses and reduced payload significantly on launches like Vulcan. This guy. Who is this guy? Massive Centaur 5 gravity losses aren't just for Leo. This applies for every trajectory in every currently planned Vulcan configuration. And by the way, for the Vulcan isn't optimized for low Earth orbit, folks. The majority of Vulcan launches for the foreseeable future will be low Earth orbit. Tori Bruno says, we are introducing a low Earth orbit optimized version of the Centaur 5, the CVL. Vulcan isn't optimized for low Earth orbit. The RL-10 is a great engine, but it's by no means... What's the context of this statement? I don't understand. I get, okay, all right. All right, I think I get it. I think I get what the guy's trying to say. He's trying to say that a low thrust upper stage is not going to be, what does he say? Hold on. The RL-10 is a great engine, but it is by no means close to the best possible for an upper stage engine. For one, its low thrust increases gravity losses and reduces payload significantly on launches like Vulcan. Oh man. Oh man. Grav losses. That's dude. What the? No, you're. I get what he's trying to say. He wants a higher TWR upper stage. You want a higher TWR upper stage so you get better low Earth orbit carrying capacity. So, you know, they're like, oh, well, like the Saturn, the S4B, right? I made this mistake too. I made the same mistake. If you want a higher TWR upper stage, right? A higher TWR would be better for low Earth orbit, right? That's true. It's 100% true, right? Higher TWR will give you better low Earth orbit carrying capacity. It'll increase your payload capacity. But it pretty much sucks at anything beyond that. I'll give you a case in point. Saturn V's third stage, okay? The S4B, right? That is 1,000 kilonewtons of thrust, okay? It has 1 J2 in the first stage. It's great. It's great for low Earth orbit insertion. They used it on the Saturn 1B, right? And it's pretty dang good for translunar injection. They used it on the Saturn V, the S4B-500. They used it for getting on a translunar injection trajectory. And the TWR basically, the thrust and weight basically, you know, made it so they could get the TWR burn done in time, right? But also at the same time, what people don't realize is that the S4B does not nearly have as much delta V as the EUS would with the same payload mass. True story. The EUS has way more delta V. Is the EUS designed to go to low Earth orbit? No. Does it have RL-10s in it? Yes. Is Vulcan designed to put stuff out at the moon? No. Is Vulcan designed for any solution between low Earth orbit and geostationary transfer all the way up to a geostationary insertion orbit? Yes. Can Vulcan move stuff to the moon? Yes. Can it do it more efficiently than any other rocket? Most likely. Because it has more, Centaur 5 will have more delta V than any other medium to heavy duty lifter rocket's upper stage. Not even close. Wouldn't even be close. It's not even a judgment call. So it's funny because like, oh, Vulcan isn't optimized for low Earth orbit. Yeah, I know, because it's designed not just to put stuff into low Earth orbit. It's designed to do a bunch of different things. Saying, I get what the guy's trying to say. I get what he's trying to say. Just that's not necessarily how that works. If an RL-10 was on a conveyor belt, bingo, Jason, bingo. It's funny because the guy's on the right track. I understand what he's saying, you know, like, I get what he's saying. You need high TWR upper stages if you want to have bigger low Earth orbit carrying capacity. But in the instance of moving Project Kuiper satellites, you just need an optimized version. You can use the same engines and it really doesn't matter. Even Tori Bruno says that right there. See? Is that what you were trying to figure out? Like, an LEO optimized version of the Centaur 5, it probably has those RL-10 CXs in it. The RL-10 CXs have 461 specific impulse, and I'll bet you they're pushing about 100 kilonewtons of thrust, probably even a little more. But this guy, once again, that guy, I'm not sure. I understand what that guy's trying to say, but you also got to understand that it's not just the low TWR, like, oh, because of optimization. Vulcan, Centaur 5 upper stages and Centaur 3 upper stages on Atlas V have very low TWR because the balloon tanks will pop if you have a high TWR engine. Balloon tanks are only rated for a certain load because they're very thin. There's basically, if you try to accelerate it too much, your fuel tanks which are balloon tanks, they will pop between the force being applied to the rocket engine being applied to the fuel tanks and the payload pushing from the top. Rocket engine pushing from the bottom, payload pushing from the top. You pop the balloon tanks. That's why they have, for instance, That's why they have a forward load reactor on Atlas 500 to help disperse the load so the Centaur doesn't pop under the accelerated forces from an Atlas 551 with 5 SRBs attached to it. See what I'm talking about? The guy wants a higher TWR upper stage. Once again, I understand what you're trying to say. I understand what he's trying to say, but the guy says, look, the RL-10 is a great engine, but it's by no means close to the best possible for an upper stage engine. Yeah, I don't think that's right. That we've been using RL-10s as upper stage engines for easily 60 years. Yeah, literally 60 years. Atlas Centaur first flew in 1962. Literally 60 years. There's a reason why we still use them. Yeah, there's a really good reason why. Because, yeah, it's unmatched efficiency. Nothing even comes close. An RL-10 with balloon tanks has way more delta V than anything. And provided you could take the load, you can get a very high TWR first stage with SRBs attached to the side, and then grav losses don't even matter. It depends on your use for them. Yeah, Novus, I think I had this conversation with you like 4 years ago or something when I was like, SLS needs Ares 5's upper stage, and you told me no, it doesn't. It really doesn't. No, it doesn't. The EUS is perfect for it. It's really good. I think we need a little more thrust out of the core stage, i.e. 5 RS-68s. And that with an EUS on top would be really nice. But I know it doesn't work like that, Again, it's all dependent on frame of reference. Swish, what are you trying to do? You got it, man. What are you trying to do? This guy is trying to take Vulcan and trying to use it as some crazy low Earth orbit access vehicle. So literally, Falcon 9 has more thrust in its second stage, so I think Vulcan should be more like Falcon 9. Flip the logic. How come rockets don't have multiple upper stages for different missions? They do? They do. Hey, Ewok, what's going on? They do, Gaw. What's a dual-engine Centaur? What's DEC compared to SEC? Single-engine Centaur, dual-engine. Atlas 5 has 2 upper stages that it can put on it. So does Delta 4. Or, well, all the configurations for Delta 4. There was a Delta 4 4+ medium and a Delta 4 5+ medium upper stage. Yeah. It's true. They did that in the 90s. It's a good idea. So hear me out. BFG with an adapted second stage and EUS upper stage. I mean, also by the end of Constellation, they were considering a 6-engine Ares 5. Oh, you can't tempt me with a good time, Novus. I mean, Novus, I don't think we should, obviously at this point, we shouldn't change anything with the SLS core stage. Should get some carbon composite SRBs on the side of that sucker. Then you don't need another engine. And if you combine that with a carbon composite upper stage in the form of the EUS with some RL-10Cs behind it, Ares 5, huh? No, we don't need Ares 5. That's better. That would be better than Ares 5. So, long story short, SLS in its Block 2 configuration with the BOLE boosters and a carbon composite EUS would be Chad tier. That would be better than the Saturn V, right? That's where I think we should go, and that's kind of where they do want to go. I think we just should have done that from the start, but that's another story. The carbon composite SRBs are happening, guys. That's happening. By Artemis 9, so that should be sometime in the later part of this decade. And then if we get a carbon composite EUS on top of that, then whoo mama! SLS will approach 170 metric ton low Earth orbit payload capacity, which means it puts you at the magic number of about 45 MT TLI, so 45 metric tons on a translunar injection. Yeah, that's a good idea. And if we figure out a way to mitigate cryogenic boil-off, the EUS can do the circularization around the moon to Gateway. So you could send an Orion and a lander and the EUS EUS circularizes around the moon. You dump the EUS, it goes into heliocentric or something, I don't know. Or you use your lander to circularize at the moon. Get to the gateway, lander goes down to the surface. Easy peasy. Carbon composite core stage LOX tank as well. Yeah, the loads, Hellfish. The reason why we can do that with the upper stage is because the upper stage isn't going to have the loads that the core stage has on top of it. You know why? Because the payload on top of the upper stage is not going to equal the mass of the EUS on top of the core stage. That would be a little bit different. You'd basically be baselining a new vehicle at that point. Core stage, we should not change. Don't change that. You can change its upper stage if you want. Change the boosters if you want. Don't change the core stage at this point. It would... You want to try to do a carbon composite tank for the core stage? Be another year. Easily. Things can change, and have already with the core stage. But it's small things that improve the manufacturability, thus reducing schedule and cost. Just not huge design changes like smart engine number. Yeah, exactly. Mm-hmm. Yeah, that would be great, Gaw. Mm-hmm. I mean, personally, I think we should go Skylab with the EUS. Literally, just you want a new commercial low Earth orbit destination. You want a new space station? Attach a space station to the front of it. Use a unmanned SLS to throw a Skylab 2 up into space, right? And use the hydrogen tank as a wet workshop. Or frick, you don't even need to do that. Just frickin' just put a thruster system. Put a thruster system inside of the payload fairing and push the entire thing. You could make the EUS into a dry workshop, Skylab style, and then just send Dragon and Starliner to it. I think that would be a great solution. It would be a great fallback for commercial low Earth orbit stuff, but yeah, you know. Anyway, summer car time?